Let's start with okay. Sorry. Okay. So coming to today's discussion, first we will be discussing a DPP 10, right? The 20 questions, and then we will follow with the new concept. And in this program, right, in CBC program, we all have included the fundamental concepts. Therefore, solving the DPPs every day is a must and should, and that is the culture of the student preparing for a JEE or NEET exam, right? So from now onwards, you have to inculcate this habit of doing the worksheet every day. That may be a exercise question, or that may be a DPP set of questions, right? But every day doing a set of questions, 10, 15, 20 questions, depending on its level, is very important, right? So let's get into the worksheet discussion. DPP 10, a metal and non-metal are likely to combine to form which type of bond? Metal and non-metal will be combining to form which type of bond? This already we know. Two non-metals will combine to form a covalent bond. A metal and non-metal will combine to form a ionic bond, and two metals will combine to form a metallic bond. So remember this point: two non-metals, covalent bond; two metals, metallic bond. A metal and non-metal opposite, then it will be ionic bond or electrovalent bond. So here one is a metal, another one is a non-metal, therefore it will be ionic bond. Very simple, right? Next, a covalent bond is formed by, we know this is also very basic point, it is already discussed in chemical bonding. Covalent bond is formed by sharing of electrons, right? Sharing of electrons. Whereas ionic bond is formed by loss and gain of electrons. Okay, na? That is a transfer of electron. Transfer of electrons will make ionic bond. Electron donation, that means electron release, will make cation formation. Electron acceptance, that means electron gain, will make anion formation. So all these are related to ionic bond only. Covalent bond formation is only of electron sharing, right? Next, in the Lewis dot structures, cross marks or dots. Cross marks means like this, and dot means like this. So in the Lewis dot structure, cross marks or dots represent electrons. Suppose I say, like in a hydrogen atom, one electron is there and it is combining with another hydrogen atom. Each hydrogen is contributing one electron into sharing. That both the electrons we will keep in the middle of the two hydrogen atoms, so that the two electrons will belong to both the atoms and fulfilling the duplet configuration, that is a helium configuration, right? So in this manner, whatever dots are in the similar manner, the same I can write cross marks like this, right? This also can lead to same structure like this. Okay, na? So this type of representation is for denoting valence electrons, whichever are the electrons which will participate in bond formation, right? Either it is ionic bond or covalent bond. Valence electrons and nucleus no, valence electrons S, kernel no, and nucleus also no. Simple question, right? So next point, the nature of chemical bonds was explained by. Nature of chemical bond. Chemical bond means basically sharing of electron, right? Or transfer of electrons, ionic bond. So whatever it is, either it is ionic bond formation or covalent bond formation, within covalent bond, sigma bond or pi bond or dative bond formation, all these are with respect to involvement of electrons. So that too, which type of electrons it is? It is the participation of valence electrons. So that indicates the option electron gas theory no, electronic theory of valence. valence electrons participation, correct, right? And electrochemical theory, no. Hybridization also, no. Hybridization is one of the very important concept that will be discussed further in higher chapters, right? Going to the next question, an element A is a tetravalent. Element A is tetravalent and another element B is divalent or bivalent. One element is a tetravalent and another element is bivalent, right? The formula of the compound formed by the combination of these two elements is, that means A will contribute 4 electrons into sharing, but B will be contributing only 2 electrons. So then how is it possible? Every bond formation is between 2 electrons, right? So 2 electrons are, 2 bonds are formed here like this. Then there is a need for another atom B in which there will be formation of 2 more bonds like this. So this results in A B2 molecule formation. So the molecule which is correct is option C, AB2, right? Now very simple, right? Then next, A is a tetravalent, means it is ready to form, it is forming 4 bonds. B is a divalent, forming only 2 bonds. So to match with A, there should be 2 B atoms there, so that totally 4 bonds can be formed as to satisfy tetravalency. Got it? Next, 2 atoms X and Y have 5 and 7 valence electrons. It is not atomic number. 5 and 7 are not the atomic numbers here. They are the valence electrons. Valence electrons means in the outermost shell. As already you have learnt how to write the electronic configuration, right? So in the outermost shell, what electrons are present is what this valence electron means. Okay, how many electrons are present in the valence shell? So X has 5 valence electrons. If it is having 5 valence electrons, means it should be something like 1s2, 2s2, 2p3. If I am considering with a second period element writing, so it will be like, it can be the element like fluorine. So 5 valence electrons are present here. 5 valence electrons are present here. Then coming to Y is the element with 7 valence electrons. So sorry, 3, 5, 7. This is not fluorine, this is nitrogen, right? Nitrogen with atomic number 7, right? And coming to the next one, Y should have 7 valence electrons. Now Y is the one fluorine element, atomic number is a 9. If you write the electronic configuration of 1s2, 2s2, 2p5, these are the 7 valence electrons, right? 5 and 7 valence electrons. So if I consider nitrogen, it is with 5 valence electrons like this, right? So how many electrons it is deficient to satisfy to reach the octet configuration? 5 are already there. If it can get 3 more electrons by sharing with the surrounding atoms, then nitrogen will reach to noble gas configuration, that is octet configuration. In the similar manner, how many electrons are there in Y? How many electrons are there in Y? Y is having 7 valence electrons already, right? Only 1 valence electron it is deficient to reach the octet configuration, right? So if I consider this is Y, this will be having, if this is Y, this will be having electrons like 1, 2, 3, 4, 5, 6, 7, right? Another Y I will take 1, 2, 3, 4, 5, 6, 7. Another Y also I will take, right? 1, 2, 3, 4, 5, 6, 7. Now there will be a bond formation between these two electrons. There will be bond formation between these two electrons. and bond formation between these two electrons. Now check it whether octet is satisfied for X or not. Yes, na? 2, 4, 6, 8. Khatam. And coming to Y, 2, 4, 6, 8. In the similar way, other Y atoms also. So this is the way both the central atom and the surrounding atoms will reach to octet configuration, right? So here along with 1x there should be 3 Y elements, Y atoms, right? Na? X, Y3 should be the compound. Okay. So where is X, Y3? This option C is correct. Okay. So going to next question. An element A belongs to second A group. Can anybody say what is this second A group element? Second A group element is nothing but alkaline earth metal. That is according to modern periodic table or IUPAC, it is the second group. What is that second group? Which elements will be present in the second group? Second group elements are beryllium, magnesium, calcium, strontium, barium, radium. Radium is radioactive, but others you can see beryllium, magnesium, calcium, strontium, barium and radium. So now he is talking about second A group element. One is the second A group element and another element B belongs to sixth A. What is the sixth A? Sixth A subgroup. A subgroup belongs to P block. B subgroup belongs to D block, right? So sixth A is nothing but a 10 plus 6, that is a 16th group element, right? So 16th group elements are chalcogens. 16th group elements are chalcogens and they are oxygen, sulfur, selenium, tellurium, polonium, right? Na? So these are the two elements he is saying. This is element A and this is element B, right? Now in this one, element A, element B, what he is saying, the compound formed between A and B contains which ions, which species, right? Na? So in this one, understand that element A is a second group element, that is alkaline earth metals. What is the behavior of metals? Metals are ready to lose the electrons, right? So this is the one which will form the cation. A is a metal, therefore it forms cation, that is a N plus, and B is a non-metal because it is a P block element, right? So it is a non-metal, therefore anion is formed. And what is the anion here? B, if this is considered as X plus and this might be Y minus, right? Na? Y minus. So in this manner the two ions will be formed, cation and anion will be formed. Now what is the value of X and Y is what we have to confirm, right? So how do we decide between X and Y is second group elements general electronic configuration is second group elements general electronic configuration is NS2. So they are ready to lose 2 electrons, therefore it forms A2 plus to reach the noble gas configuration. And 16th group general electronic configuration is ns2 np4. That means in the valence shell already 6 electrons are there, 2 more only electrons are required to reach the noble gas, nearest noble gas configuration, right? Therefore this will form B2 minus. A is having 2 valence electrons, so it will lose the electrons and will reach to the previous noble gas configuration, so A2 plus. And B is already having 6 valence electrons, so it will be gaining 2 more electrons and reaches to the next noble gas. This reaches to before noble gas and this reaches to next noble gas configuration, right? So this forms B2 minus, and here x and y values are same, so it is 1:1 ratio. Therefore A1 B1, so that is simply to be written as AB. Molecule is AB, right? So the answer will be A2 plus B minus wrong, A2 plus B2 minus correct. Both the charges on cation and anion should be same. That is what you can understand here. Then coming to next one, the cation is isoelectronic with anion in. Isoelectronic, do you have the idea what is isoelectronic means? Iso itself indicates same. Electronic, the name itself is having electrons, same number of electrons. The species which are having same number of electrons are called isoelectronic species. It is not the comparison about protons or neutrons. It is only the comparison of electrons. If electrons are in same in number, not the valence electrons, entire number of total number of electrons should be same, then they are isoelectronic species. Right? So now sodium chloride. In sodium chloride, do we have isoelectronic species? Sodium, potassium, lithium, rubidium, all belonging to same group. Let us write the group elements: lithium, sodium, potassium, rubidium, right? And coming to anions, all anions are here. With the sodium, chloride is there. Then with the potassium, bromide is there. Lithium plus, sodium plus, potassium plus and rubidium plus. Cl minus, Br minus, lithium fluoride, then rubidium bromide, Br minus. So here one thing you can understand, these are the ions, right? One thing what you can understand is lithium fluoride. When lithium fluoride is there, that means this compound is there, lithium atomic number was 3, but from 3 electrons, 1 electron it lost and became helium configuration. Lithium plus is having only 2 electrons, right? So this is having 2 electrons, and fluorine is F minus. Already 9 electrons are there, and it gained one of the electron from lithium, so it became 10 electrons. So 210 electrons are not same number of electrons, so remove it. Then coming to sodium and potassium. Sodium ion, sodium atomic number is 11, from which it lost 1 electron, so it became 10 electrons here. And chloride. Chlorine atomic number is 17, and it gained 1 electron from sodium, it became 18, right? So these also different in number, so eliminate this one also. Coming to potassium bromide. Potassium, what is the atomic number? Potassium atomic number is 19. So 19 losing 1 electron becomes 18 electrons. And what about bromine atomic number? Fluorine is, this already I have told you earlier in the previous class also how to find the atomic number, right? Na? So suppose if you say, for atomic number I am saying, from lithium to sodium, lithium is 3 na, atomic number, right? So if lithium is 3, you have to add 8 so that it becomes 11. To this you have to add another 8, it becomes 19. To this you have to add again 18, it becomes 18 plus 18, 36 plus 1, 37 is the atomic number of rubidium. Rubidium, right? In the similar manner, if you write the atomic number of fluorine as 9, right? To this you are adding 8 so that it becomes 17. To the 17 if you add 8, it becomes 35, and then to the 35 if you add 18, sorry, there is no iodine, so this is also 35, right? So now coming back to this one, potassium bromide. So this is a potassium, already 19 electrons were there, from which 1 electron is lost, it became 18. And bromine 35 electrons, but it is forming anion, so 35 plus 1, that is 36. So this is also not same in atomic, same in number of electrons. And last one is rubidium bromide. Rubidium bromide, Rb plus, Br minus. Rb plus, what is atomic number? 37, but it lost 1 electron, so it became 36 electrons. And bromide, bromine is atomic number is 35 and it gained 1 electron, so it becomes 36. So it is matching, both are having 36 electrons, so the answer is rubidium bromide. Rubidium bromide. Understand this point, right? So finding out the atomic numbers of any elements is very important. For that you should know how to recognize the position of element in the periodic table. So that is what already we have discussed under basics of periodic table. Everybody has to by heart and able to write the entire periodic table, right? In this summer session, the time you come to college, right? Everybody should be able to write the entire periodic table, all the blocks, S, P, D, F, all the 4 blocks, right? Now going to the next question. The maximum valency of sulfur is, the one which it can involve maximum number of electrons into bond formation is 6. As sulfur is a third period element, it has a vacant d orbitals. So by using that vacant d orbitals, it can utilize or it can participate all of its 6 electrons into bond formation. So maximum valency of sulfur is 6. Or you can say in another way also, like suppose in sulfuric acid, sulfur oxidation number is plus 6. So which can indicate, or even in sulfur trioxide plus 6, which can indicate that sulfur is involving all its 6 electrons, 6 valence electrons, right now. Then next, the valence of the metal atom with respect to oxygen is maximum in valence of metal atom, that means oxidation number of metal atom with respect to oxygen is a maximum in. Let us calculate here in Mn2O7 O2 minus, so each oxygen minus 2 into 7, how much it will come to? That is minus 14, and that minus 14 should be balanced by plus 14. If this is a minus 14 in total, this should be plus 14. So plus 14 is for 2 manganese together. So each manganese will be of plus 7. Right? In the similar way, osmium tetroxide. So each oxygen is a minus 2. So minus 2 into 4 minus 8. So single osmium is there which has to balance the entire negative charge. Therefore it will be plus 8. So osmium plus 8. Then coming to MnO2. Here each oxygen is minus 2. So minus 2 into 2 minus 4. So that to balance it is a plus 4. Mn 4 plus. Then fourth one is a CrO3. Oxygen is a 2 minus. So minus 2 into 3 minus 6. To balance it, it should be plus 6. So chromium plus 6. So you can understand with oxygen which element, which metal atom is having highest or maximum covalency here. Valence here. Maximum valence in these species, you can only compare. So this is 7, 8, 4 and 6. Maximum valence is by osmium, right? So answer is osmium tetroxide. Simple na? Next, electrovalence of electrovalence is basically related to ionic bond. We all know it, but the question is incomplete actually here. Electrovalence of, I think there should be there some continuation of the question should be there. Highest electrovalence or least electrovalence, something should be there, right? So if it is of a highest electrovalence, then it will be with a fluoride, aluminium fluoride, right na? So let's see next question. Maybe this is an incomplete question actually. He is not saying what is needed. Next, in covalence, transfer of electrons takes place, sharing of electrons takes place, sharing of electrons by one atom only, none of these takes place. In covalence is nothing but formation of covalent bond. In covalent bond formation, we know it is sharing of electrons to happen, but the sharing is mutual. Both atoms will contribute some number of electrons and both together will share that electrons, right? So transfer of electrons really leads to ionic bond formation. Sharing of electrons takes place, this is correct, by both the atoms. Sharing of electrons by one atom, this is wrong, and as anyway answer is there, option D also will go wrong, right? Simple question. Then coming to next one, the nucleus of an element has 9 protons. Its valency would be, the nucleus of an element has 9 protons. The nucleus of an element has 9 protons. Its valency would be. Who is the element which has 9 protons? The element with 9 protons is with atomic number 9. That is fluorine, right? Fluorine is the element he is talking about. 9 is the atomic number. 1s2, 2s2, 2p5, right? It's a valency. Valency is right, how many number of bonds it will form with the surrounding atoms. As it is deficient of one only electron, it will be sharing that electron or it will be gaining that electron. In ionic bond formation, it gains that electron and forms one ionic bond. And if it is in a covalent bond formation like CF4, carbon tetrafluoride, it will be sharing its 7th electron, so that carbon also will share one electron and it forms one bond. So valency will become one only here. It will gain or share one electron here in order to reach the octet configuration. Okay, so this is also simple question. Sorry. Next, which of the following is not a property of covalent compounds? Is not a property of covalent compounds. They have low melting points. Generally, covalent compounds melting point is low only. That is correct only actually. They are not electrical conductors. This is correct. This is correct. Low melting point, this is also correct, but he is asking not a property of covalent compound. That means the option should not match to the covalent compounds. This is matching to the covalent compounds, this is matching to the covalent compounds, and they exhibit space isomerism. This also actually will match. This is one option, one point which you may not understand now, but it will be discussed in detail in higher chapters in 11th and 12th. Exclusive isomerism related chapters are there, like in stereoisomerism, organic chemistry, and in coordination compounds also. In 12th standard we will be discussing this one. So for right now, just let us not break our head in understanding this point. It will anyway come in detail in next chapters. They undergo chemical reactions quickly. This is one point which will not match with covalent compounds to the perfectly, to the exactly. To some extent it is okay, because there are some covalent compounds whose reactivity is higher. But if you compare with ionic compounds, covalent compounds reactivity will be lesser, because they are in a neutral molecule formation, that sharing of electrons will be there with sigma and pi bonds, right. Whereas in ionic compounds, ready-made ions will be available, so easily they can show the influence on other surrounding or nearby ions, right. But here in covalent compounds, reactivity order will be little lesser. So this can be one statement which will not match covalent compounds, Then next, the most favorable condition for electrovalence is nothing but ionic bond formation. Everybody knows this one, right. So electrovalence means ionic bond formation, and between two species, if a highest electrovalence has to be maintained, highest ionic bond has to be maintained, then the charges on the ion should be lower. This is one point. So you can eliminate this and this. Then large cation, small anion, large cation, small cation will have a higher Z effective. So this is also wrong. So this can be the statement, large cations and small anions. This is a one condition actually which will be discussed in chemical bonding. So little more information, knowledge is required in solving this question. So maybe right now you can understand that highest ionic bond percentage can be maintained with lower charge on both cations and anions, a big cation and small anion. So straight away you try to remember these conditions, and later on what are the background reasons for each and every point, that also we will be discussing. Okay. So this is the answer. Then coming to reaction between X and Y forms compound Z. X and Y are reacting to form compound Z. X loses electrons and Y gains electrons. X is losing electrons and Y is gaining electrons, means what type of compound is formed here? The compound Z is ionic compound. And he is asking which of the following properties is not shown by Z, means which of these four properties is not a property of ionic compounds, right. Has a high melting point, this is a property of ionic compounds. Has a low melting point, this is not the property of ionic compound. Generally in ionic compounds, melting point will be higher, right. In covalent compounds, melting point will be lower, but there are exceptionally some covalent compounds whose melting points are very high, right. So we are not going into exceptions. In general, if you compare, the ionic compounds melting points will be higher and covalent compounds melting point will be lower. So this is one point which will not match ionic compounds. So this can be the answer here. And conducts electricity in a molten state. So in ionic compound, whether it is in the aqueous state or in the molten state, conductivity will be shown, because even in the molten state also mobility of ions is possible. Therefore conductivity or conductance will be there, electrical conductivity will be there in the molten state also. Occurs as a solids, crystals in particular, the ionic compound, this is also matching, right. So it has a low melting point is the general point what you can consider for not matching for ionic compounds, but will match for covalent compounds. Okay. Next, atomic numbers of four elements A, B, C and D are 6, 8, 10 and 12. A, B, C, D. and atomic number, that is Z, is 6, 8, 10, 12 respectively. The two elements which can react to form ionic compound, ionic bond. The two elements which react to form ionic compound is this is the one which has valence electrons 4, right? Why? Because A atomic number is 6, its electronic configuration is NS2, or I can directly write it, this is carbon. So I can write it as 1s2. 1s2, 2s2, 2p2. So 4 valence electrons are there, 4 more are required. So this will be forming covalent compound, covalent bond, right? Going to next element B, B atomic number is 8. So this will be having 6 valence electrons. So 2 more only are required. So it will gain 2 electrons and will form B2 minus. So this will form ionic bond. And C is having 10 electrons, means already octet is there. This is the neon, element neon. So no reaction, no bond formation. And coming to 12, this is magnesium. Magnesium has 2 valence electrons, so it will lose these 2 valence electrons to form D2 plus, and so B2 minus and D2 plus are the two which will be forming the compound DB. DB is the compound formation. So AD, B and C, A and C, B and D. Khatam. Right na? So next, ionic bond is formed between this. In the starting of today's class itself, I have told you ionic bond is formed by one metal and one non-metal, right na? Metal and non-metal. So going to the next one, compared with the covalent compounds, electrovalent compounds generally have. Compared with the covalent compounds, electrovalent compound, that means ionic compound generally have higher melting points and higher boiling points, right? Because of the strong electrostatic attractions between the cations and anions. So low, wrong, low, wrong, low, wrong, both high melting point, high boiling point. This is correct statement, right? So going to the last question here. Which of the following is not an ionic compound? Which of the following is not an ionic compound? Barium carbide. Barium is one strong metal atom, so it will form ionic compounds. So it is an ionic compound. Then Al2O3, oxygen, aluminium 3 plus and oxygen 2 minus. Then calcium hydride, calcium 2 plus and hydride. Then aluminium 3 plus, Cl minus. So chloride ion, bigger ion is there, and aluminium 3 plus ion is there. So between them there can be strong sharing of electrons between the cation and anion. That ionic character can decrease and little will increase the covalent character. That you can say that AlCl3 is not an perfectly an ionic compound. It will be having more of covalent nature. So it is something like a covalent compound, right? So this is the last question. Now going to chal. So now let's start with the new topic, right? Physical parameters. One of the very important concept, for it will help you for the entire physical chemistry when you are into 11th and 12th standard. Very basic point only we will be discussing, very simple small topic, right? So some of you might be knowing also from the 9th and 10th standards. So that is the physical parameters. Physical parameters. So in this concept physical parameters, we are going to discuss the first physical parameter, pressure. Pressure, right? And pressure is like, how do you define in physics? Anyway, already you have studied also. Pressure is a force per unit area. Force per unit area. To the unit area with how much force it is giving, how much force it is giving, the object is giving to the unit area will indicate pressure, like in balloons or closed containers or atmospheric pressure, different ways, right? Force per unit area is pressure. So in different ways pressure can be measured. It is measured have you heard of in any units the pressure will be measured? One of the most common way the pressure is measured is in atmospheres. Atmospheres, right? What is the atmospheric pressure? That means the air altogether will create how much pressure on the objects? That is 1 atmosphere pressure. So in atmospheres it can be measured, then in newtons per meter square it can be measured, then in dynes per centimeter square it can be measured, then it can be measured in millimeters of Hg pressure or centimeter of Hg, right? Millimeters of Hg, 760 millimeters or 76 centimeters of Hg. I hope you have heard of this one. In millimeters of Hg or centimeters of Hg, then in bars also it can be denoted, then in newtons per meter square is nothing but pascals. Pascals also, sorry, Pascal. Pascals also we can measure this one, right? So here what the conversion we should understand, we should know between different units here is 1 atmosphere. This is the reference actually. 1 atmosphere is equal to 760 centimeter of Hg. 1 atmosphere is equal to 760 centimeter of Hg or 1 atmosphere is equal to 760 mm of Hg or 76 centimeter of Hg, or 1 atmosphere is also can be given as a 1.013 bars. 1.013 bars, or it can also be given as a 1.013 into 10 to the power of 6 dynes per centimeter square, or it can also be given as a 1.013 into 10 to the power of 5 Newton per meter square. So in different ways the units can be converted. So we should know all of them, because in questions, right, they can give in a different types of units. Dynes per centimeter square is CGS system, right, and newtons per meter square is SI system, and frequently it is the SI system we will be using during calculations, but we don't know, even in questions they can ask in the CGS system also. This interconversions we should must and should understand. So these are the units in which pressure can be expressed, and these are the interconversions between different units. 1 atmosphere is equal to 760 mm of Hg or 76 centimeters of Hg, 1.013 bars, 1.013 into 10 to the power of 6 dynes per centimeter square, or 1.013 into 10 to the power of 5 newtons per meter square, because each 1 Newton per meter square is 10 dynes per centimeter square. Right? That will be discussed later also in units and dimension chapter in physics subject. Right? So this is about pressure factor. Then we will be discussing the next factor, that is a volume. Right? This is a volume. And volume, you know, right? So volume is something like it is to measure how much is occupied, how much space is occupied by some particular gas or object or liquid or anything. Right? So how much space is occupied three-dimensionally is denoted by volume factor. Right? Space occupied. And volume is also given in a different units, like it can be given in liters, it can be given in ml, milliliters, it can be given in cc, nothing but a centimeter cube, cubic centimeter. That is what this one, centimeter cube or cubic centimeter. Or it can be given in a meter cube, like in a different ways volume can be given. Right? And 1 liter, we know 1 liter is 10 to the power of 3 ml, 10 to the power of 3 cc, because 1 ml is 1 cubic centimeter. 1 ml is 1 cubic centimeter, right? And 1 liter is 10 to the power of minus 3 meter cube. This also you can understand, right? So in this manner, ten to the power of minus 3 meter cube. Okay. So in this manner, you can have the interconversions also. So these are the units in which volume can be expressed, and these are the interconversions. They may be given in liters or milliliters or cc, that is a cubic centimeters, or a meter cube, etc. Meter cube is what? SI unit, right? Centimeter cube is cc, means centimeter cube, that is a CGS system, right? So this is about volume factor, volume physical parameter, very simple, right? Then the third physical parameter is temperature. Temperature. Temperature is a scale to measure the hotness or coldness of a body. Hotness or coldness of a body. Suppose you say, tea is there, right? So if the freshly prepared tea, right, from the stove, it is just given, so you feel that it is hot, right? And cold coffee is there, right, which is made with the refrigerated items, so you feel that that is cold. And suppose water is given from the purifier at home, that is as like a normal, either it will not be either hot or cold. So this is with respect to the our temperature or the atmospheric temperature. So hotness or coldness, already the atmosphere will be having certain temperature, to which in comparison you will be saying it is hotter than that or colder than that, right now. And simple point is that suppose this thermometer is there. So in thermometer the value will come, right, 98.2, 98.2 Fahrenheit, which indicates that there is no fever. So if it is above that, like 99, 100, 102 Fahrenheit temperature is there, you say that there is a temperature, right? So and if it is below that, like refrigerated items are there, they will be with a lower temperature. So our body temperature is 98.2 degrees Fahrenheit. So altogether you might have got some idea that temperature is one physical factor, one physical parameter by which you will be measuring how much hotter it is or how much colder it is, right, with a scale. And three different scales are used, right, in day to day or normal life, as already everybody knows it. One is a Celsius scale or degree Celsius. Second is a Fahrenheit, that is what in temperature in thermometer, whatever just I told you. And Kelvin scale is also possible, Kelvin scale, right. So temperature to measure hotness or coldness of a body, to measure the hotness or coldness of a body, right. So temperature is measured in units like Kelvin, degree Celsius, or degrees Fahrenheit. Degrees Fahrenheit, right. So these are the three ways in which temperature is measured, right. So it is like one sorry suppose if temperature is given in degree Celsius, right, how it can be converted into Kelvin is whatever the value is there in a degree Celsius, to that you have to add 273.15 Kelvin. So you will be getting in Kelvin, right now. Or if it is given in Kelvin, you have to subtract 273.15, okay. And the same degree Celsius, if you want to convert it into Fahrenheit, it is something like degrees Fahrenheit into 9/5 plus 32. This will give you conversion of degree Celsius to Kelvin and degree Celsius to Fahrenheit, right. So in this manner interconversion can be done from one scale to another scale also, okay. So this is about temperature scale. Now coming to the final factor, that is energy, right. Fourth one, energy. Energy and work both will be having a same units, right. So energy units different. The very frequent, very commonly used energy units I will tell you. Energy unit is like first one is like a calorie. Then we also use joule. Joule is what, SI unit. Then we can use ergs. Then we can use this is SI, this is CGS. Then we can use electron volts. Then we can use kilowatt hour. Like in a different units we can use energy, right. and how to interconvert energy in whatever units we have taken into different things. So 1 calorie is equal to 1 calorie is equal to 4.18 joules, but 4.18 joules every time to consider it is difficult, that it will be considered like 4.2 joules. 4.2 joules. 1 calorie is equal to 4.2 joules, and 1 joule is equal to 10 to the power of 7 ergs. 10 to the power of 7 ergs. That means 1 calorie is equal to 4.2 into 10 to the power of 7 ergs. So in this manner, in different conversions also we can use energy term. So in this manner, these are the four most important physical parameters which will be required, or the entire physical chemistry concepts will be handled in these most important 4 parameters. First one is pressure, then second one is a volume, third one is a temperature, fourth one is energy or work done, right? So pressure is force per unit area, and volume is space, 3-dimensional space occupied by matter. Then temperature is a scale to measure how much hotness or coldness a body has, and energy or energy or work done, that already we know it. So these are the 4 physical parameters most important. You can revise the theory part given in your CBC material also, and solve the DPP 11 worksheet for tomorrow's class. So first we will discuss DPP 11 questions, and then we will go to the next chapter, right now. So hope you have understood this today's concept, right? So we will meet tomorrow and we will wind up it here. Thank you. Right now.
Dear students, good morning. Let us start where I had stopped on Friday. I was on Newton's laws of motion. So in the beginning, we have to start with Newton's first law. That day also I have discussed your Newton's first law. Again, a bit recap. Every body continues its initial state of rest or uniform motion along a straight line path unless it is acted upon by a net external force. I told you from Newton's first law how many concepts we are getting. First, concept of rest and motion I have explained to you. Concept of inertia. Inertia is of three types: inertia of rest, inertia of translatory motion, and inertia of direction. One by one, you will be talking about all three types of inertia. Inertia of rest, the inertness or inability of a body to change its initial state of rest by itself is known as inertia of rest. So many examples that day I have quoted. One more example you take today. Suppose there is a glass. On the glass, you are keeping 1 minute. Now, you are taking a glass, and on this you keep a postcard and put a coin here. Okay, no? You have a coin here. This is the coin. Now, coin is at rest. Your postcard is at rest. Give a jerk to postcard simply like this. You hit. The moment you will be hitting, you will be finding that coin will fall in the glass. How it is happening? It is happening because coin is at rest. Coin want to continue its initial state of rest. So when postcard moves fastly, coin want to continue its initial state, and that is rest. Now postcard is not there. What will happen to coin? Coin will fall in the glass. Clear to you? So many examples you can take. A blanket you take. And you are cleaning your clothes now. You are washing your clothes. You are washing now. After washing, before putting on wire for drying, what you are doing? You are giving a jerk. Why you are giving a jerk? Some water, whatever is sticked onto your cloth, due to inertia of rest, it will fall down. Same thing you are doing with carpet. When you are cleaning your carpet, two persons will be holding and you are giving a jerk. A very interesting thing is there, that two persons are holding the carpet and they will give vertical oscillation. Okay, no? When you are giving vertical oscillation, dust particle due to inertia of rest, it will like to continue that position. So carpet will move and dust particle will have free fall. But if you are not moving carpet away, then again dust particle will fall onto carpet. So in my opinion, when you are dusting a carpet, give the jerk but move carpet away, side by, so that carpet due to inertia of rest, whatever dust particles are stick to the carpet, it will fall down onto the ground. Clear? This is inertia of rest. The inertness of the body to change its initial state, of rest by itself is your inertia of rest. You are getting this concept from Newton's first law. Inertia of translatory motion. If any particle, any body is moving along a straight line path, uniform motion with constant velocity, body will like to continue its motion along a straight line path with same velocity. It will not like to change its initial velocity by itself. Okay, no? So when you consider this, many again examples you want to take, so many examples in day-to-day life you are seeing. From a running bus, you are coming out, jumping out. The moment your feet will come in contact with the ground, your feet will come to rest. But your upper part of the body will like to continue its motion. So what will happen? You will fall in forward direction. If this example you would not take, then many times you kids have sat on bike. If all of a sudden they are applying brakes on running bike, what happens? If you are a pillion rider, you will move in forward direction. The person who is driving will be hitting him. What happens there? The feet which is in contact with the bike will come to rest when bike will be stopped. Okay, no? But your upper part of body will like to continue its motion. Due to that, your body moves in forward direction. Clear? Again, the inertness or inability of a body to change its initial state of translatory motion by itself is known as inertia of translatory motion. Third, you take inertia of direction. Yesterday it was raining, right? And I was on a bike. In front of me a car was going. From the wheel, rolling wheel, the mud particles were flying tangentially, directly landing on my shirt. I was coming from backside. You have felt this. So from a moving wheel, mud particle or water molecules will fly off in tangential direction. This is nothing but inertia of direction. Means in whatever direction body is moving, body will like to continue its initial state, and that is of direction. So you are getting concept of inertia of rest, inertia of translatory motion, inertia of direction from Newton's first law. Right? Mass gives the measurement of inertia. Only mass. I have checked in many questions, they are asking about whether it is depending on velocity, whether it is depending on linear momentum. No. Inertia only. Inertia of translatory motion, inertia of rest, all these are depending only upon mass. Simply remember, mass will give the measurement of inertia. Clear to you? This is concept of inertia which you are getting from Newton's first law. Third and most important concept, even Helde Resnick has told you that Newton's first law is nothing but a statement related to inertial frame of reference. In kinematics only I have told you that whenever you consider inertial frame of reference, what is frame of reference? In this three-dimensional world, to express any vectorial parameter, what you need a coordinate system. A frame of reference is nothing but a coordinate system will have one origin, will have x-axis, will have y-axis, will have z-axis. Now this three-dimensional frame of reference will be of two types, right? Inertial frame of reference and non-inertial or accelerated frame of reference. Slowly I am telling this point, you must understand clearly. It will help you to solve a lot of problems, and whatever I am going to say to you about these frames of reference, you may not get in your usual books. Right? Inertial frame of reference is that in which Newton's laws of motion hold good. Point number one. In non-inertial frame of reference, your Newton's laws of motion will not be true. Inertial frame of reference is that frame of reference which is either fixed or which moves with constant velocity with respect to distant star. But here there is a catch. We are small kids. We study motion of body on the surface of earth. We are not studying motion of satellite, motion of galaxy. So slight modification we do. Yes, it is not true. It is not correct. But we are modifying it. A frame of reference will be considered to be inertial if it is either at rest or it moves with constant velocity with respect to earth. It is not correct. It is with respect to distant star only. But with respect to earth we are considering, because our most of the motions that we study, it is with respect to earth. But if anyone is asking you, hey, really define what is inertial frame of reference, then you will consider with respect to distant star only. But for solving problems in our dynamics or even in kinematics, you consider a frame of reference to be inertial if it is fixed or moves with constant velocity with respect to earth. Now, listen carefully. Then a non-inertial frame of reference will be that frame of reference which is neither fixed nor moves with constant velocity with respect to distant star. And a star, again you can change with respect to earth. Any frame of reference which is accelerated can be considered as non-inertial frame of reference. Simple example I give you. Okay, no? A car which is accelerating on the road, any circular motion you take, a giant wheel. You know that in circular motion a centripetal force is continuously acting. Without centripetal force, a body cannot move on a circular path. So giant wheel, motion of giant wheel is in, if you are considering a frame of reference fixed with respect to a giant wheel, it will be a non-inertial frame of reference. A non-inertial frame of reference along with, see, if you want to solve a problem in non-inertial frame of reference along with real forces, you need to consider some fictitious, some imaginary force. I'll be quoting example for that. Right now, if you move from one frame of reference to other frame of reference, now what kind of frame of reference? If you are moving from one inertial frame to other inertial frame, any phenomena will not change. One simple example I will give you. Before giving example, let me complete this sentence, that if you are moving from one inertial frame to other inertial frame, phenomena does not change. So any physical parameter associated with phenomena is not changing. But if you move from one inertial frame to a non-inertial frame of reference, means if you move from one inertial frame to an accelerated frame of reference, phenomena is changing. Right now, to explain any phenomena, clearly listen and use it for solving problems. What I said to you, if you move from one inertial frame to other inertial frame, phenomena is not changing. Any physical parameter associated with phenomena will not change. But if you are moving from one inertial frame to an accelerated frame of reference, phenomena will be changing. The value of physical quantity will be changing. Right? If you want to explain any phenomena in inertial frame of reference, you have to consider only real forces. If you want to explain a phenomena in non-inertial frame of reference along with real forces, you need to consider some pseudo force. I am quoting one example, you will understand. In the beginning I have quoted, I have a lift. I have a lift. On the lift, there is a weighing machine, okay, no? And on this, a person is standing, okay, no? This one is a weighing machine. On this weighing machine, a person is standing. What will be the reading of weighing machine if, suppose, mass of the man is m? Right now, what will be the weight of the man when lift is at rest with respect to ground? If lift is at rest with respect to ground, what kind of frame of reference you have? Frame of reference is inertial. You need to consider only real force. So his weight will be equal to m into g. Clear to you? His weight of the man will be mg. Now, suppose it is moving up with certain velocity 5 meter per second. Let us take A. Velocity you have taken V, 5 meter per second. What will be the reading of weighing machine? It will be again mg. When lift is at rest, frame of reference is inertial. When lift is moving with constant velocity with respect to earth, again frame of reference is inertial. the any physical quantity will not change, weight of the man will remain constant. Not only 5 meter per second. You take 10 meter per second, 50 meter per second, 100 meter per second, lift is going up, lift is going down, whatever you like you take. Frame of reference will be inertial. When frame of reference is inertial, weight of person will not change because phenomena is not changing. To explain that, what you are doing, you have considered only real force, that's mg. Are you following my line? If lift is going up or lift is coming down with any velocity, W will be only mg. But now, change frame of reference. Now suppose the same lift is going with an acceleration of 5 meter per second squared. Now what will happen? Frame of reference has changed from inertial to non-inertial. Now phenomena will change. Now weight of the man will not be mg. You will have to take a pseudo force, a fictitious force. The reading of weighing machine now will become mg. If it is going up, you have to take pseudo force downward, m into a. Clear to you? So the reading will become mg plus ma. The reading is mg plus ma. If lift is coming down with an acceleration a, if lift is going down, here you have taken up, then pseudo force will have to take upward, right? Then weight of the person will become mg minus ma. Very, very interesting. Why it is interesting? You can become a Spider-Man. Okay, and no need of any special, okay, jacket and all. How? Suppose you are standing in a lift and lift is coming down with an acceleration a equal to 2g. A equal to how much? 2g, lift is coming down. Then what will be the weight of the man? Weight of the man will become now mg minus ma, you have told, no. So it will become mg minus m 2g, it will become minus mg. Same person, same lift is coming down with acceleration 2g. Now weight of the man becomes minus mg. So he will now stand on the roof, feet up, head down, and he will not fall down also. He will not feel uneasiness also. Okay, to understand this a bit in depth, I am telling you, let us think how it is happening, from where pseudo force is coming. Okay, no. To understand this, why we need a pseudo force to explain a phenomena in non-inertial frame of reference, I am quoting one example. Okay, no. Simple example. Right? Suppose there is a dark room, everywhere dark. In that dark room, there is a round table. And at the circumference, a white illuminated dot is there. Radium like we are getting now. A small dot is stick to the circumference of the table. You are sitting at the center of table and I am standing in one corner of the room. room completely dark. I can't see you, you can't see me, we can't see table, but both of us are capable to see the dot. Right? Now, table is slowly rotated so that you should not feel that table is rotated. Now, what I will speak about motion of that white dot, I am not able to see anything. I will see only a dot, it is moving in circular path. What I will say, that dot is not in equilibrium, it is moving in circular path. So a centripetal force is acting towards the center. Simply I will say that. But what we will say, you are sitting at the center of the table, dot is in front of your eye. As much table is rotated, that much you are also being rotated. Now, dot is in front of your eye, and always it is in front of your eye. Right? You will feel that dot is at rest. You are in non-inertial frame of reference. I am standing on the ground, I am in inertial frame of reference. For me, dot is moving in circular path. For you, dot is at rest. For me, a centripetal force is acting on the dot towards the center. For you, dot is at rest, net force is 0. Now, we two are talking. I will tell that dot is moving in circular path, a centripetal force is acting. You will tell, no sir, dot is not at rest, dot is not moving in circular path, sir, dot is at rest. I will tell, no beta, a centripetal force is acting towards the center. To explain what you feel, along with real force, a pseudo force you will imagine. And you know that that pseudo force is centrifugal force. You will say, sir, whatever force you are feeling, centripetal force, one more force is acting, sir. That force is equal in magnitude, opposite in direction, sir. So net force acting on the dot is 0, so dot is at rest. Actually, this force, centrifugal force, is pseudo, fictitious, imaginary. I am not seeing, I am in inertial frame. To explain the phenomena, I am not considering centrifugal force, you are imagining. Who will see centrifugal force? Who is situated in non-inertial frame of reference. A teacher has asked me, sir, what is the basic difference between centripetal and centrifugal force? Can you compare these two forces? I simply have asked, can I compare you from a ghost? Teacher is telling me, sir, why you are getting anger? Well, I am not getting anger. I am giving answer for your question. Yeah. I can compare a real thing from a real thing, na? How can I compare a real thing from a pseudo thing? Centripetal force is a real force. Centrifugal force is a pseudo force. Then teacher has asked, sir, can we consider it as action and reaction pair? How can you consider? Action and reaction both are acting on two different bodies. Here, the person who is in non-inertial frame of reference have considered centripetal and centrifugal, both forces acting on the same body, just to explain what he is feeling. Did you understand? When we will be solving problems on Newton's laws of motion, we will be showing you more. One topic we have kept in CBC also, what will be the weight of a person in a lift? There also you will be using these concepts for solving the problems. So, from Newton's first law, most important concept you are getting, that is concept of inertial frame of reference. Clear to you? And last concept which you are getting from Newton's first law is qualitative concept of force. That is definition of force. Force is that external agency which will change or tries to change the initial state of the body. If body is at rest, if force will act, force will like to change its initial state of rest. Will change, may not change. Both are there. This wall is there. I will exert force. Can I change the position of wall? No. Because inertia of wall is more. It does not mean that I have not exerted a force. The force is that external agency which is changing or trying to change the initial state of the body. If a body is moving with constant velocity, it will produce acceleration or retardation in the body. It may produce, may not produce. But generally, if a force is acting, it will change the initial state of the body. Did you understand? This is about Newton's first law. In brief, I have explained to you about first law. Now, come for Newton's second law. Okay, now, for second law, first word you should know right now. What is linear momentum? For second law, I want to clear what is the meaning of linear momentum. See, if you consider linear momentum, mass times velocity. Undoubtedly, whatever role velocity plays, it doesn't give complete information related to motion of a body. If you want complete concept, mainly for collision, you have to take product of mass and velocity. So, linear momentum, first word, it's a vector quantity. When you multiply a scalar quantity to a vector quantity, resultant will be a vector quantity. The magnitude of vector will be scalar times magnitude of vector. So, if P equal to mv, magnitude of P will be mass times magnitude of velocity vector. When you multiply scalar to vector, resultant is a vector, direction of vector will be that vector quantity. So, direction of linear momentum will be direction of velocity vector. So, P will be equal to mass times velocity. Magnitude of P is mass times magnitude of velocity vector, and direction of this will be direction of velocity vector. Okay? What is the statement of Newton's second law? According to Newton's second law, right, the rate of change of linear momentum of a body, the rate of change of linear momentum of a body is directly proportional to net external impressed force on the body. It may be possible on a body, so many forces may act. You have to take net resultant force. Then rate of change of linear momentum will be proportional to that net external force. You need not to consider any internal force acting on the body. Right? And this change of linear momentum will occur in that direction in which net force has acted. From this Newton's second law, you are getting the quantitative concept of force, means a mathematical formula for force, the basic formula for force. In a simple way, we can derive. Suppose I have a particle, its mass is m, and it is moving with velocity u. Right? Let us take a frictionless floor and it is moving with velocity u. According to Newton's first law, it will be moving, continue to move with velocity u if no external force is acting. Suppose in the same direction, if this direction you are considering as x, suppose in positive x direction. Okay, no? In positive x direction, you have exerted a force. When you exert a force, its velocity has changed to v in time t. Understanding now? So what is change of velocity? Your change of velocity, this will be equal to v minus u. Actually, I can take even a vector form. If you want, you can take v minus u, you can take in vector form. And this change of velocity has occurred in time t second. So what will happen to rate of change of velocity? This will become v minus u by t. Okay, no? Right? And this will be known as acceleration A. Are you understanding? Now, take initial linear momentum. What is initial linear momentum? This is P initial, this will be equal to mu, right? After time t, its velocity has changed. You know that whatever Newtonian mechanics we study, in that we are usually not considering change in mass. Mass always we take constant. Right now, the initial linear momentum is m into u. And after time t, its velocity has changed to v. So what will be final linear momentum? Final linear momentum, this is P final, this will be equal to mv, mu and mv. So what will be your change of linear momentum? In time t, change of linear momentum, this is equal to mv minus mu. This is your change of linear momentum. This change of linear momentum has occurred in time t. So what will be rate of change of linear momentum? Rate of change of linear momentum, this will be equal to mv minus mu by t, right? Let us use this symbol. It is del p by del t. So, del p by del t, you got m v minus u by t. And v minus u by t, already you know it is acceleration. So, this is nothing but m into a. And now, according to Newton's second law, this rate of change of linear momentum is directly proportional to applied force. So, this ma is proportional to, you take F, proportional to ma, F will be equal to Kma. K is constant of proportionality. There are only 2 or 3 ways to find the value of constant. First, applying initial condition. Number 2, it will depend upon the units or system of units in which physical quantities are being expressed. You take any system of unit, CGS, FPS, SI, any system of unit, it was experimentally observed by Newton, value of K was found to be 1. If you will take the value of K1, you are obtaining F equal to ma. The famous from class 7th or 8th onwards, you have studied about this formula, F equal to ma. Now, take what will be SI unit for force. You know that mass in SI kilogram, acceleration meter per second squared. To give honor to Newton, Sir Isaac Newton, the greatest scientist, one of the greatest scientists, we honored him by putting SI unit for force as Newton. So what is 1 Newton? In all 3 system of units, I will be going on telling you. Okay, no? You will be considering in CGS system, unit to be dyne, dyne. In SI, Newton. In the FPS system, poundal. Very easy. Poundal. I remember like kundal, poundal. Like this I remember. Right now? To be in our syllabus only SI is there. So mostly we are considering Newton. What is 1 Newton? First, basic concept. I have a body of mass 1 kilogram. I have exerted a force. When we have exerted the force, if body is getting an acceleration of 1 meter per second squared along the direction of applied force, we say that the magnitude of that force is 1 Newton. Means 1 Newton is that force which when acts on a body of mass 1 kilogram, it will produce an acceleration of 1 meter per second squared along the direction of exerted force. Tell me, did you understand this clearly? Yeah, this is magnitude of force, formula for force, quantitative measurement of force which you are obtaining from Newton's second law. In that way, we can derive Newton's first law also from Newton's second law. You'll tell, how, sir? In one line we can derive. See here, F is mv minus u by t. What is your Newton's first law? When no net external force acts on the body, body will continue its initial state, either of rest or of uniform motion along a straight line path. You consider here mv minus u by t. Now your f is 0. When you consider f to be 0, what will happen? This is mv minus u by t. Now mass of the body can't be 0. Time for happening of any event, time will be passing. You will always be moving from present towards future. You can't go to past. In Newtonian mechanics, you can go in relativistic mechanics. Relativistic mechanics in that way is very, very interesting. Time can be dilated, time can be contracted. Right? No. But here in Newtonian mechanics, T, okay, also will take constant. So what will happen? You will have V minus U equal to 0. It means V equal to U. This is nothing but Newton's first law. You have obtained from Newton's second law. Clear, no? From here, even conservation of linear momentum and all, so many things are there we will derive. Okay, no? But later on, in IIT, conservation of linear momentum, collisions, all these units will be separate units. Whereas for MSET and all, or intermediate, all these we study here. I will be talking about conservation of linear momentum in brief a bit later on. Let us complete all the three laws. Tell me, Newton's second law is clear to you? A statement you remember, derivation for an expression for force you remember, definition of Newton you remember. In intermediate exam they ask this. Derivation also they are asking. Clear? Now come to Newton's third law. Who is not knowing third law? What you are thinking? It's very, very easy. Yeah? When I was child, I was thinking that in all the three laws, the most difficult law is Newton's third law only. Every action has equal but opposite reaction. No? Damn easy. When I was a small child, when I was studying in a school, no, 9th, 10th class, I was very lean, thin boy. In your school also it will be happening. Some bodybuilder boys would be there. No, they'll be bullying you. They were coming, they were giving one hand. Move to back bench. Right? I was telling, okay, I am reading Mahatma Gandhi, his book. So when they were hitting, no, action. From my side, there was no reaction. You know the obvious reason. I was not that much physically stronger. When my teacher has told every action has equal but opposite reaction, I asked from my teacher, sir, why Newton's third law does not obey Gandhian philosophy? Only action should be there. There should not be any reaction. My teacher was not giving any answer for this question. In my brain, so many questions were coming. Always reaction happens after action, na? You have shouted on your mummy. Afterwards, what your mummy will do, you know. Reaction is happening after action, na? You have fever. You have taken medicine. You are being cured. First action, no, then reaction, na? But in physics, both are simultaneous process. What do you mean by that? In simple language, that whenever force takes birth, a single force will never take birth. Always they will take birth in pair named action and reaction. Why? Why whenever force will take birth, they will take birth in pairs? It is a question now. Next question will be, if two forces are taking birth at the same time, then which one is named as action and which one is called as reaction? First, why we will not get a single force? All these questions I will be giving answer to you when you will be coming near us. Right now, so don't take lightly. People will sometimes, whatever is looking very simple, no, will be very, very difficult. So this Newton's third law, even a rickshaw wala knows, okay, no, don't think it is so simple law. Yukawa got Nobel Prize for it when he had explained the origin of nuclear force in pairs in 1966. Japanese scientist. Okay, no? So, in too much depth, we will be discussing in resonance about these things when you will come near us. At this time, I am just considering every action has equal but opposite reaction. But every pair cannot be considered as action and reaction pair. I am just taking one example. Suppose on a table, a body is being kept. So mg is acting downward and normal reaction is acting upward. Block is at rest, body is at rest. In vertical direction, net force acting on the body is 0. Because unless net force will not be 0, body will not be at rest. So mg equal to n. So they are equal and acting in opposite direction. But these two are not action and reaction force. And just few minutes ago, I have told you about centripetal force and centrifugal force. When a body is moving in a circular path, you are considering a circle, a particle is there. Okay, no, let us take a string and a ball you have tightened and you are rotating it in a circular path. A centripetal force is acting towards the center and centrifugal force is acting radially outward. Centripetal itself means to sit towards center. The centripetal force is acting towards the center, centrifugal force is acting outward. Will you consider them as action and reaction pair? I have already told you, one is real force, other is pseudo force. You can't compare a ghost from a real person. So how can you compare centrifugal force from centripetal force? So they are not action and reaction pair. Clear to you? For centripetal force, reaction force will be centripetal reaction, it will be acting at the center. It is not centrifugal reaction. Clear to you? If you understood all these three laws in brief, I have told you in brief, right? Based on this Newton's third law, so many things you know. Motion of rocket, gas is ejected in downward direction, rocket is moving in upward direction. When you are swimming, you are pushing water in backward direction and your body is moving in forward direction. Same thing for rowing of a boat. When you are walking on road, okay, no? When you are walking on a road, then this is ground, you are exerting force in this direction, normal reaction, if you will be considering the reaction of the force, what you are exerting will be this. It will have two components. This angle is theta, suppose this is n, this is f, this is n cos theta, this will be n sin theta. Your n sin theta is balancing your weight, and due to n cos theta, your body is moving in forward direction. You are walking also on the road due to Newton's third law. Okay, no? On the bank of a river, you are standing in a boat. Okay, no? You have jumping outside towards the bank. Boat will move in backward direction. You are firing a bullet from a gun. Bullet will move in forward direction and gun will move in backward direction. In conservation of linear momentum, we'll be using that. We'll be deriving conservation of linear momentum by using Newton's third law. Clear to you? I will come back on conservation of linear momentum tomorrow. Before that, let us start the basic problems on Newton's laws. Okay, no? We are taking first the class work. If A and B are two objects with masses of 10 kilogram and 30 kilogram respectively, they are asking you about inertia. What is inertia? Okay, no? I have taught you today only. Which physical quantity will give the measurement of inertia? Take inertia will be also, again, inertia, you are taking here raised translatory motion. If in that way you will take, we will have inertia of rotatory motion also. In rotatory motion, I will teach you that inertia of rotatory motion, moment of inertia will give the measurement. Here, mass gives the measurement of inertia. So they are asking you, which one has more inertia? The A has mass 10 kilogram and B has mass 30 kilogram. Which has more mass? B. It means MB is greater than MA. Whose inertia will be more? Undoubtedly body B. B has more inertia than A. In a simple way I can say, a small stone is there and a big stone is there. Right now, hit. You will be hurt more when you will be hitting bigger stone. Okay, no? See, dance also, if a lean thin man is there, he will dance more fastly. But if there is a fat man whose mass is more, to change the initial state of the body by a fat man, he'll have to exert more force. It will be too difficult for him. So his frequency of oscillation will be less. Understanding? Clear to you? Yeah? Let us move now to next question. Inertia depends upon. Just now I have told you, inertia depends upon mass of the body. Mass is more, inertia is more. Mass is less, inertia is less. If inertia is less, less effort is required to change its initial state. If mass is more, inertia will be more. You need a larger force to change its initial state. So here, inertia depends upon mass of the body. Answer will be D. Clear to you? Let us move now to next question. Which of the following has the largest inertia? Now they are giving you 4 different bodies. A pin, your physics book, your body, an ink pot. They should tell about the mass. General mass you will have to consider. A pin, very less mass. Then ink pot. Nowadays, who is using ink pot, beta? Okay, all of you are using ball pen only, na? In my time, when ball pen was not there, we were using ink pot. We are using pen. Right now, a small glass bottle filled with ink. But mass of ink pot will be more than mass of pen. Then your physics book. It depends upon which physics book you are taking. Nowadays, so much thick physics book is coming. So mass of physics book is more than mass of ink pot, mass of pen. Of your body. Beta, your body, minimum 50-60 kg you will be now. If I will take my mass, it will be 80-90 kg, beta. Whose mass is more? Your body in comparison to other 3. Whether everything in the world is relative. Right? If I talk about which will have largest inertia, in these 4, if we compare, undoubtedly inertia of your body will be more, so your answer will be your body. Clear to you? Let us move now to next question. Inertia of rest is the property by virtue of which body is unable to change by itself. Whenever you have to identify whether it is inertia of rest or inertia of translatory motion, check what is the initial state. If initial state is that of rest, that is an example of inertia of rest. Suppose a bike is at rest and all of a sudden you started, pillion rider will fall backward. Example of inertia of rest. Why? Bike was initially at rest. You are on a bike and bike is moving. All of a sudden bike was stopped. Initially bike was in motion. So that is example of inertia of translatory motion. So here inertia of rest is the property by virtue of which body is unable to change by itself the state of rest only, the state of uniform linear motion, the direction of motion, the steady state of rest. This is inertia of rest. So this is a state of rest only. Are you understanding now? Clear to you? If you understood this, then now let us move to next question. An iron ball and aluminium ball have the same mass. Inertia will be more for which ball? Just now, same concept they are using. How nicely, beta, different examples they have quoted for same concept, so that you people should get all concept clearly. It is not like that we are repeating same concept. We want to give you clear concept from our CBC book, so that your fundamental concept foundation should be stronger. Our iron ball and aluminium ball both have same mass. Our inertia depends only on mass, no, not on the body. The inertia of both the ball undoubtedly will be same. So here your answer will be both the ball have same inertia. Did you understand? If you understood this, now let us move to next question. A man sitting on a train in motion is facing the engine. Now it depends upon train is moving or train is at rest. Okay, let us assume train is moving. The engine is moving in this direction and man is sitting here, because they say you man sitting on train in motion is facing the engine. The engine is this side, man is facing the engine. He has tossed a coin up and the coin falls behind him. If coin falls behind him, it means horizontal distance traveled by train is more than the horizontal distance traveled by the coin. It means train is accelerated in forward direction. Simple. Suppose beta, I am walking with constant velocity and I'll throw a coin up. The coin will have two velocity. One vertical direction what you have given, after time 2u by g, it will come to your hand. But at the same time, in horizontal direction also, coin will have velocity or ball will have velocity. That is your horizontal velocity. Clear to you? So when man sitting on a train in motion is facing the engine, and when he will toss the coin and coin is falling backward, coin should fall in his hand. If train moves with constant velocity. If train is being accelerated, what will happen to coin? At that particular instant, whatever train will have velocity, that will be velocity of the coin in horizontal direction. And now, train is accelerated. So, train's velocity is gradually going on increasing. The coin will fall backward. If coin will fall in forward direction, it means that motion of train is retarded. All three cases I am telling you. If coin is falling backward, train is accelerated. If coin is falling in forward direction, means train velocity is going on decreasing, motion of train is retarded. If train is falling in the hand of the person who has thrown the coin vertically up, train is moving with constant velocity. So here they say you coin is falling behind him, so train is accelerated forward, means it moves in forward direction with certain acceleration. Tell me, did you understand this? If you understood this, then your classwork I have completed. Will continue with homework, okay, no? Homework tomorrow, and at the same time, whereas theory is concerned, I will be discussing about conservation of angular momentum, normal reaction I will explain to you, free body diagram I will explain to you, tension I will explain to you. All these things, basics I will be teaching you tomorrow. Okay, no? As much it will be possible, but before that I will complete this homework. Okay? Thank you for today. Have a nice day. Always be happy and cheerful. We are always there to help you. Thank you again.
Good morning, students. So we were discussing about sequence and series, and we have completed sequence series. So today we'll be doing about AP and GP and sets also, right? So I've given you homework for AP GP. So today we'll be discussing that. All right. So let's see the first question. It is saying if the pth term of the series is what, right? It is saying pth term of the series is what. So if you can see here, this is the first term. Oops. Yes. So I was saying this is the first term, right? This is the second term. This is the third term. Correct? Okay. So this is the first term, right? Second term and third term. So what I can say, just a minute, this is a new board. In the first term, you can see there is 1 year. Second term, there is 2 year. Third term, there is 3 year, right? That is only changing. And apart from this 3, the first 3 is remain constant everywhere, right? If it is constant everywhere, can I say it is going to be there in the pth term also? In the pth term, this will also be there, right? 3. Now, minus upon n is also same in everyone, right? In everything, n is also there, correct? So what I can say in the pth term, what will be changing this position? So first term in first is 1, second term it is 2, third term it is 3. So it will be how much? 3 minus Pn. Right? It will be how much? 3 minus Pn. So the correct option for this will be how much? B. Right? 3 minus Pn. So the correct option for this is how much? B. Alright. I hope this question is clear. This is very simple. Right? We just need to find a general term or the pth term. Okay. Next question. 8th term of the series 2 root 2, 0. Like that it is equal to what? Now first of all you need to think what this series is, right? Is it a AP? Is it a GP? Is it a HP? What it is? So this is 2 root 2, right? This is root 2, this is 0, right? So what I can say, if I say it is a GP, that will not be valid. Why? Because root 2 upon 2 root 2 will give me half, right? And 0 upon root 2 will give me 0. So it will not be a GP. Now let's think of a AP. If I think of a AP, what will I get? I need to have root 2 minus 2 root 2 should be equal to 0 minus root 2, right? So I will be getting minus root 2 is equal to minus root 2, and this is correct, right? This is something which is correct. If it is correct, then I can say it is an AP, right? It is an AP. For an AP, we need to know the common difference and the first term, right? So in the first term of this AP is how much? This. So A will be equal to 2 root 2. Right? And common difference will be equal to what? Minus root 2. Right? Because root 2 minus 2 root 2 will be what? Minus root 2. Correct? Okay. Now we have A and we have also D. So what I can say, we need to find the 8th term. So T8 will be equal to A plus 8 minus 1D. Right? A plus 8 minus 1D. It will be equivalent to what? A is 2 root 2. Plus 7 minus root 2, right? So it will be how much? 2 root 2 minus 5 root 2. Sorry, minus 7 root 2, which will be how much? Minus 5 root 2. So the correct option for this is how much? A. Right? The correct option for this is how much? A. Understood? I hope it is clear for everyone. Question third. The 9th term of an AP is 0. Then the ratio of its 29th term to 19th term is equal to what? Right? Ratio of its 29th term to 19th term is equal to what? Okay. So 9th term of an AP is 0. So T9 is said to be 0. Right? What is going to be T9 of an AP? A plus 8D is equal to 0. Right? So can I say from here that A is equal to minus 8D? Right? Can I say A is equal to what? Minus 8D. Okay. Now what they are asking? They are asking the ratio of T29 is to T19. Right? That will be equal to T29 upon T19. Right? T29 upon T19. What is T29 will be? Right? This will be equal to A plus 29 minus 1D. Right? And this will be equal to what? A plus 19 minus 1D. Am I correct? Okay. So this will be equivalent to what? A plus 28D, and this will be equal to A plus 18D. Right? And we know the value of A. A is how much? Minus 8D. So I can put it here. Right? The value of A is what? Minus 8D. If I put it here, what do I get? I get minus 8D plus 28D upon minus 8D plus 18D, right? Which will be equal to 20D upon 10D, which will be equal to 2, right? Which will be equal to what? 2. If it is 2, then can I say that this ratio is going to be 2:1, right? If it is 2, can I say the ratio is going to be 2:1? So the answer is what? 2:1, right? The answer is 2:1 in this case. Okay, I hope this question is clear to everyone. Question 3. Then next question, question 4. What it is saying? The fourth term from the end of the AP is minus 11, minus 8, minus 5, so on till 49. Right? Minus 8, 11, minus 8, minus 5, so on till 49 is right. Then fourth term from the end is what? They have given us the first term. They have said it is AP. They have given us the first term. Then they have given us the last term. Right? So can I say A is equal to minus 11 and last term is equal to 49. Right? And common difference will be minus 8 minus minus 11, which will be how much? 3. Right? Which will be how much? 3. So we know the common difference. We know this. Right? Now what they are asking? Fourth term from the end. Right? Fourth term from the end. So if this is L, right, the term preceding it will be what? L minus D. It preceding will be what? L minus 2D. And preceding this will be what? L minus 3D. Right? So this is the last term, second last term, third last, and this is the fourth last. And that's what they are asking. What is the fourth term from the end? So fourth term from the end will be how much? L minus 3D. Right? L minus 3D. So last fourth term will be what? L. L is how much? 49. Minus 3 into D. D is how much? 3. Right? So 49 minus 9, which will be how much? 40. So the answer will be what? B. Right? The correct answer for this question will be what? B. Understood? I hope this question is also clear. It's a pretty simple question. Just we need to know that from the last if I do, right, it will be subtraction. Okay, that's the only thing we need to know in this question. Okay, next. Fifth question. The 16th term of the AP 15, 25 by 2, 10, 15 by 2 and 5, right? 15, 25 by 2, 10, 15 by 2, and they have given it as an AP. They have given it as an AP. So let's find the common difference. If I find the common difference, I can say it is 25 by 2 minus 15, which will be 25 by 2 minus 30, right? Which will be how much? Minus 5 by 2, right? So D will be how much? Minus 5 by 2, right? If D is minus 5 by 2, we need to find 16th term. We know the first term also, right? We need to find 16th term. So 16th term will be what? For 16th term, what I will do? T16, right? T16 will be equal to what? A plus 16 minus 1D. What is A here? A is 15, right? A is what? 15. So 15 plus 15 into D. D is how much? Minus 5 by 2. Right? D is how much? Minus 5 by 2. Right? So this will be equal to what? 15 minus 75 by 2, which is equal to 30 minus 75 by 2. Right? Which will be equal to minus 45 by 2. Right? So the answer is in this option is what? Option B. Right? Option B is saying minus 45 by 2. Okay? I hope this question is also clear. right? This question was pretty simple. Just we need to know the common difference and we need to find T16. Okay, I hope this is also clear. Let's go to the next one. Sixth question. What it is saying? If 9ab minus 6 are in arithmetic progression, then a plus b equal to what? Right? A plus b equal to what? Okay. So this question can be done in two ways, right? What are the ways? That we know that the sum of the term equidistant from the start and the end will be same, right? So what I want to say is that a plus b should be equal to directly 9 plus minus 6, right? 9 plus minus 6. So this will be equal to how much? This will be equal to 9 minus 6, 3, right? So directly answer will become what? D, right? So and there is one more argument to prove this. How? Because see 9, a, b and minus 6, right? So let's say this is the last term, right? This is the first term. So can I say this is what? A plus d, and this will be what? L minus d. Right? This will be what? L minus d. So if I want to add this a plus b, it will be how much? A plus d plus L minus d. D and d will cancel. So again I'll get a plus L. Right? I'll get a plus L. And what is a plus L? A plus L is equal to what? 9 plus minus 6, which is what? 3. Right? 9 plus minus 6, which is what? 3. Understood? I hope this is clear to everyone. Right? Let's do the next question. Find the sum of this infinite GP. Okay, in infinite GP you just need to know the common ratio, right? Common ratio, if you know, you can get the answer. So for infinite GP, what I will say, what is the first term of this sequence? First term is equal to 1, right? And R is equal to what? 1 by 3 over 1, which is 1 by 3. Right? R is what? 1 by 3. So what is the sum of infinity? So S infinity is how much? S infinity is equal to A upon 1 minus R. Right, which is 1 upon 1 minus 1 by 3, which is 1 upon 2 by 3, which is 3 by 2, right? Which is how much? 3 by 2. Okay, I hope this question is clear to everyone, right? Let's do the next one. The first term of a GP is 7, right? The first term of a GP is what? 7. The last term is 567, right? The last term is 567. And the sum of term is 847. Find the common ratio of the GP, right? Find the common ratio of the GP. They have given the first term to be how much? 7. Last term, right? It is how much? 567, right? And the sum of the terms also they have given. Sum of terms S n is equal to what? 847. This is last term, means this is also can be said Tn, right? This is what? Tn. Find the common ratio of the GP, right? Common ratio. Okay, so first I will try to use this Tn, right? What is Tn? Tn is A into R to the power n minus 1, right? This is given to be how much? 567, right? It is given to be how much? 567. Now if I put the value of A here, it will be 7 into R to the power n minus 1 is equal to 567, right? So R to the power n minus 1 will be 567 divided by 7, right? 567 divided by 7. If I divide 567 by 7, what I am going to get? I am going to get 81, right? I am going to get 81, correct? And what is 81? 81 is actually 3 to the power 4, right? 81 is actually what? 3 to the power 4. So directly on comparison, I can say that R will be equal to 3 and n minus 1 will be equal to 4. So n is equal to 5, right? N is equal to what? 5. Now we can verify this thing also, right? With Sn, what we have assumed is right or not. So what I will do for this, I will use Sn. Sn is what? Sn is A into 1 minus R to the power n upon 1 minus R, right? A into 1 minus R to the power n upon 1 minus R. This is given to be how much? 847, right? So if I put the value of A and R, let's see whether we get the right answer. So 7 into 1 minus 3 to the power. What is n? N is 5. So 3 to the power 5 upon 1 minus 3, right? So it should be equal to 847, right? So let's see. So 7 into this will be 242 divided by 2, which is going to be 121, right? And if I multiply 7 with this, I will get 847. So what we have assumed is actually right, right? What we have assumed is actually right. So the correct answer for this question is what? R they have asked. R is equal to what? 3, right? R is equal to 3. And if they ask n also, right? N, number of terms of this particular GP, so it is what? 5, right? N is how much? 5 in this case. Understood? I hope this is clear to everyone. Okay, let's do the next question. The sum of odd numbers between 0 and 50, right? The sum of odd numbers between 0 and 50 is how much? Okay, right? So what will be the first odd number? First odd number will be how much? 1, right? Then 3, then 5, then so on till 49, right? This sum we need to find, right? Sum of odd numbers between 0 to 50 are what? 1, 3, 5 to 49, correct? Now how to find the sum? We can either use we know the first term and the 49th term, so I need to find n first. So Tn formula I'll apply. I will get a plus n minus 1 into d, right? A plus n minus 1 into d. So I will write 49 is equal to 1 plus n minus 1. D will be how much? 2 actually, right? 3 minus 1 is how much? 2. So D will be classified as how much? 2. So now what I'll have? 49 minus 1 divided by 2 is equal to n minus 1, right? So 48 divided by 2 is equal to n minus 1. This will be 24. So I will have n is equal to 25, right? I will have n equal to what? 25. We needed to find what will be the number of terms, right? We needed to find what is the number of terms. I have got n to be 25. Now I can just apply the formula of Sn. Sn will be what? 25 by 2, first term plus last term, right? First term plus last term. So it will be equal to how much? 25 by 2 into 50, which is 25 into 25, which is 625, right? Which is how much? 625. All right. I hope this is clear to everyone, right? The answer is what? Option A, right? Answer for this question is option A. All right. Okay, let's do the next one. Okay. 10th question. The sum of last two terms of an AP is 60, right? The sum of last two terms of an AP is what? 60. And if the first term is 11 and the common difference is 2, then the number of terms in this AP is what? Right? Common difference is 2. Okay. The sum of last two term. So let's say what will be the last two term here? L and L minus D, right? So this 2L minus D they have given to be how much? 60, right? 2L minus D they have given to be how much? 60, right? And they have given the first term to be 11. Okay, so we know A is equal to what? 11, right? And they have also given the common difference. Common difference is what? D is equal to 2, right? So if D is equal to 2, I can plug in it here and see what do I get. So I'll get 2L minus 2 is equal to 60, right? So 2L is equal to 62. So L will be equal to 31, right? We got the last term, right? We got the last term. If we got the last term and we know the first term and the common difference, I can apply the formula L is equal to A plus N minus 1D, right? What is L? L is 31 is equal to 11 plus N minus 1 into 2, right? Which will be 31 minus 11 is equal to 2 into N minus 1. So I will have 20 divided by 2 is equal to N minus 1, right? Is equal to what? N minus 1. So can I say from here that N minus 1 will be equal to 10 or N will be equal to what? 11, right? I can say N will be equal to what? 11. So the correct answer for this will be how much? C. Understood? N will be equal to what? 11. Alright. I hope this is clear to everyone. Then 11th question, right? 11th question. What 11th question is saying? Ram gives his son 100 rupee on one day, right? On one day or day one, right? Rupees 50 on the second day, rupees 25 on the third day, and so on, right? What will be the total amount given by Ram to his son starting from the first day if he lives forever, right? If he lives forever. Who is living? Ram and his son both are living forever. So they want to find what will be the total money he will be giving to his son, right? So we just need to find the sum of the series, right? So what is the series here? S is equal to 100, right? Plus 50 plus 25 plus so on, correct? So what kind of series this is forming? If I divide 50 with 100, I am going to get what? Half. And 25 with 50 also I am going to get half, right? So you can say this is an GP, right? This is an GP, and that too which GP? It is infinite GP, right? This is an infinite GP. In infinite GP, I just need to know what is the first term. First term is 100, and I need to know R. R is equal to what? 50 upon 100, right? Which will be equal to what? Half, right? R will be equal to what? Half. So I have A, I have R. Now I can find sum to infinity, right? What will be the sum to infinity? S infinity will be equal to A upon 1 minus R, right? S infinity will be equal to what? A upon 1 minus R, where A is 100 upon 1 minus half. So it will be 100 divided by half. So it is equal to 200, right? It will be equal to how much? 200, correct? So the answer for this question will be how much? A, right? The answer for this question will be how much? A. All right. I hope this question is also clear to everyone. 11th question. Then the next question. The third term of a GP is 9. The product of first 5 terms, right? The product of first 5 terms is, okay. So what they have given? The third term of a GP they have given. What will be the T third of a GP? It is AR square. It is given to be what? 9. Right? AR square is given to be what? 9. They are asking the product of first 5 terms. First 5 terms. So basically AR, AR square, AR cube, and last AR to the power 4. Right? This they are asking. So if you see, this is the product. This is the first term, second term, third term, fourth term, and fifth term. Right? So if I see in this, what are they saying? How many A's are coming here? How many A's are coming here? There are 5 A's, right? 5 A's. So 5A means A to the power 5. And R to the power is 1 plus 2 plus 3 plus 4, which will be A to the power 5, R to the power 5 plus, so this is how much? 1 plus 2, 3, 3 plus 3, 6, 6 plus 4 is 10. So it is R to the power 10. Correct? R to the power 10. So what can I say from here? I can say it is A R to the square to the power 5, right? A R square to the power what? 5. And that A R square is how much? 9, right? So if I put it here, I'll get 3 to the power 5. No, not 3. It is 9 to the power 5, right? And what is 9? 9 is actually 3 to the power 2 into 5, right? Which is 3 to the power 10, right? The correct answer for this question is how much? 3 to the power 10, right? 3 to the power 10. So which is the right option for 3 to the power 10? It is option C, right? It is option which one? C. All right. I hope this is also clear to everyone. This was the last question. Okay, no, 13th. 13 is the last question, right? Okay. Let's see if the sum of W numbers in the GP, right? Sum of W numbers in the GP 5, 10, 20, dot, dot, dot is 1275, right? Is 1275. Then K is equivalent to what? Right? Then K is equivalent to what? Sum of W numbers in the GP. So if I say W numbers, I think there is some error in this question. Let me check in the book, because there is W numbers and then there is K. We are not able to find K in this, right? So let me check in the book what is the error, and then anyway we going to start set. Actually it is sum of n numbers, right? It is sum of n number. Give me a minute. So we need to find the sum of n terms, right? This is n. This is a printing mistake. This is n, right? So if we need to find the sum of n terms, we need to find n, right? They have given the sum of a GP, right? So what is the sum of n terms of a GP? Sum of n terms of a GP is what? A into 1 minus r to the power n upon 1 minus r, right? A into 1 minus r to the power n upon 1 minus r, right? This is given to be how much? 1275. And what is A? A is 5. So 5 into 1 minus r to the power n upon 1 minus r is equal to 1275. Right? Okay. R also we know in this. R will be equal to what? 10 divided by 5, which is equal to what? 2. Okay. So if I divide this, anyway I am going to get 255. Correct? And if I put the value of 2, 1 upon 1 minus 2 is equal to what? 255. Correct? So it means that this is equal to 2 to the power n minus 1 is equal to 255. Right? Then I can say that 2 to the power n is equal to 256. It means that it is equal to 2 to the power 8. So I can say n is equal to what? 8. Right? If on comparison, I'll get n equal to how much? 8. So the correct answer for this question is how much? C. Okay. So I hope this all the 13 questions are clear. So we have discussed the worksheet number 11 of sequence series. We have completed sequence series also, and now we'll be doing with sets. Right? We'll be starting with a set. This is the last chapter of the CBC. Right? We'll understand the different types of sets, and we'll also understand the different terms, right? How to write the representation of set. Correct? So let's start set one by one. So let's start sets. Okay. Right. Now what is a set? Right. Let's understand what is a set. Right. Set. What is the definition of set? Right. So set you must have already learned in your 10th standard or your 8th or 9th standard. Right. What is a set? Set is a collection of It's a collection of objects, right, or numbers, right? Collection of objects or number, right? Well-defined objects or number, right? They should be what? Well-defined. They should not be like subjective, right? That is a basic definition of a set, right? Collection of well-defined objects or number is what? A set, right? So for example if I write if I write this, right, that A is a set of all the students who are tall, who are tall, right? Now tall is something which is subjective, right? Tall is not well defined. For some people, tall can be like 6 feet. For some people, tall will be like 5'10". Tall will be like 7 feet. So tall is not well defined, right? But if I say, let's say that A is collection of all the students having height more than 6 feet, right? So this means a set, right? This is the actually meaning of a set. So they have clearly defined that the students should be more than 6 feet, right? Tall is not well defined. So the first one is not a set. Actually, the second one is a set, because in this case we are defining that the students should be more than 6 feet. Understood? Right? So this is the meaning of a set. Okay. Now, right, that is a basic definition of a set. Now let's do the next thing. Right? Some letters are reserved for representing numbers. Right? So what are those sets? Let's understand. So n, right? Whenever they will give you n, capital letter N, what does this denote? N denotes set of natural numbers. Right? N denotes what? Set of natural number. Right? Second, W. What is W? Set of whole numbers. Right? What is W? Set of whole number. Then Z. Z, what does it denote? Z denotes set of integers. Right? Then Z plus, set of positive integers. Right? Set of positive integers. Then Z minus, set of negative integers. Right? Set of negative integer is what? Z minus. Then next is Q. Q denotes set of rational numbers. Right? Set of rational numbers. Then Q dash. This denotes set of irrational number. Right? And last Q dash, and then last will be what? R. Set of real numbers. Right? Set of real numbers. So this is a representation of different letters reserved for a particular set of numbers. N for set of natural numbers, W for set of whole numbers, Z is set of integers, Z plus is set of positive integers, Z minus is what? Set of negative integer. What is Q reserved for? Q reserved for set of rational numbers, Q dash reserved for set of irrational number, and R is reserved for what? Set of real numbers. Alright, let's go to the next one. Okay, now we'll see description of a sets. Right? Method of representing a set. Methods of representing a set. Right? Method of representing a set. So the first one is what? First one is roster method. Right? First one is what? Roster method. Now what does roster method says? It says, in this method, a set is represented by listing all the elements in the set, right? Listing all the elements in the set. For example, A is A E I O U, right? For example, A is what? A E I O U. So what does this mean? This means it is set of vowels, right? But actually we are not just writing set of vowels. What are we doing? We are writing here the actual vowels. A E I O U, right? So that is how it is represented in roster method, correct? So if I want to write down set B 2, 3, 5, 7, 11, 13, 19, right? 2, 3, 5, 7, 11, 13, 19. These are what? These are set of prime numbers less than 20, right? Set of prime number less than what? 20. Understood? So this is how we represent the set in a roster method, in which we actually list all the elements present inside the set. Alright? This is the meaning of roster method. Okay. Next. Suppose, okay, now there is one important note in this. What is the note? I will add it in the next slide. One important note is there in this. The order of elements, right? The order of elements inside the set, inside the set doesn't matter. Doesn't matter, right? So instead of writing 2, 3, 5, 7, if I write 3, 2, 5, 7, the set will remain the same. The set will not change, right? Set is always the same. Only the order can be changed inside the particular set. It will not change the set, right? This is the first note, right? What is the next note? Let's see. Next is set builder method, right? Next is what? Set builder method. Next way of representing a set is what? Set builder method, right? Set builder method. Now what does set builder method means? It means, right, in this method, right, we represent the set. We represent the set by characterizing a property, by characterizing a property P of x of its elements x, right? Of its element x. So basically what we do, we don't actually write the elements, we write the property. So like in the first one, in the previous slide, this set will be written as what? Set of vowels, right? This set will be written as what? Set of prime numbers. Understood? Okay. Oops. Set builder method, right? Next is what? And how do we describe? For example, this we example write in this way. X is such that P of x holds this property, right? X is such that P of x holds this property. So for example, I can write A is a set x such that x is a set of all the vowels, is a set of all the vowels in the English alphabet. In the English alphabet. Right? It is the set of all the vowels in the English alphabet. Actually, this method is what? Set builder method. And if I want to write the same thing in roster method, it will be what? A, E, I, O, U. Right? These are two ways of representing a set. Understood? Alright, so this is the definition of set. Now we'll be seeing what are the types of set. I hope these two methods are clear. roster method and set builder method, right? These things is you must be already cleared with, but now we have, since we have revised, right? Now it will be more clear that what is a set builder method and what is a roster method, right? Now we will be doing with the next types of sets, right? Next types of set. Types of set, right? In this first is what? Empty set. In this first is what? Empty set. What does empty set means? Empty set is very simple. A set containing no elements, right? Containing no elements or zero elements, right? Or zero elements is called, right? Is called an empty or null or void set, right? Empty, null or void set. There are three ways of writing this: empty, null or void set. Okay, I hope this is clear to everyone. What is the meaning of empty set, and the way of representing the empty set is what? We represent it by this way, phi or this, right? These are two ways of representing a empty set. This is also represented an empty set, this is also represent an empty set, right? Okay, now but many student does a mistake that, right, we need to write a note that, right, this is not an empty set, right? This is not an empty set because it contains an element, right? In this set, in this bracket, there is a set. Which set? Null set. So that's why it is not an empty set. Understood? The right way of representing an empty set is what? Phi or this bracket. Okay, both are fine, but one inside the other is not correct way of representing. Understood? This in fact contains an element, right? This in fact contains one element. Okay, I hope this is clear to everyone. Then next, right, singleton set. Then second is what? Singleton set. Right, singleton set. A set consisting of a single element. A set consisting of a single element, right? So for example, if I want to write A is equal to 2, right? In fact, this also, as I have told, this is what? A singleton set, right? This is actually what? A singleton set. Understood? Why? Because it contains one element. If it contains one element, then we'll say it's a singleton set. Alright? Very basic, very nothing to explain here, right? Now, next is finite set. Next is what? Finite set. Okay. Now, what is a finite set? A set in which the number of elements can be counted, right? Then it is a finite set, right? It is a finite set. Okay. Now in this case, in a finite set, both singleton set and empty set and singleton set are what? Finite set, right? Because in void set also, right, I can count the number of elements, which is what? 1. And in singleton set also I can count the number of elements. Sorry, in void set we can count the number of elements, which is 0. And in singleton set we can say the number of elements is what? 1. So both of these are example of what? Finite set. So void and singleton set, right? Void and singleton set both are example of what? Finite set. Understood? Okay. So one more example if I want to write, I can write it here. Example: A is equal to 2, 3, 5, 7, 11, 13 and 19, right? These elements can be counted, right? If it can be counted, we can say that it is a finite set, right? If it is counted, we can say it is a finite set. Okay, now let's go to the next one. Infinite set, right? Next is what? Infinite set. Right, what does infinite sets definition can be, right? Infinite set as a definition is saying, right, a set whose elements are not countable, right? Are not countable, right? If it is not countable, then we'll say that it is an infinite set, right? For example, A is equal to X such that X is a set of even numbers, right? A is a set of even numbers. Now, how many even numbers are there? Infinite, right? A is a set of even number. For example, B, X is such that X is a set of natural numbers, right? Set of natural numbers. So this is what B is what? Again, set of natural numbers are infinite, so we cannot count that. That's why it is will also be set into what? Infinite set. Okay, I hope this is clear to everyone. Infinite set. Now, I'll write few example. You have to tell me whether they are infinite or not. Okay, infinite or finite. So example, first is set of concentric points in plane, right? Second, set of letters in English alphabets, right? Set of English. C, X belongs to natural number and X is greater than 5, right? D, X belongs to R 0 to X 1, right? And next, right? E, X belongs to natural number, X is less than 200, right? X is less than 200. Now we need to identify which of them is finite, which of them is infinite. So what does the first one is saying? First one is saying that whether they are set of concentric point. What is a set of concentric point? Set of concentric points means what? They are having the same center, right? Say same center. So there it will be what? How many points will be having a same center, right? Concentric points, right? It will be infinite, right? It will be infinite. So if I consider two circles, right, they have the same center, then we'll say set of they are what? Concentric points. So there will be infinite circles in a plane. That is why we'll say it is infinite. So the first one is what? Infinite, right? Second, set of letters in English alphabet. Set of letters in English alphabet. How many letters are there in English alphabet? 26, right? We all know there are 26 letters in the English alphabet. So we can count it. So that's why it is finite, right? That is, it is finite. Understood? And then next, X is a natural number and X is greater than 5. Right, X is greater than 5. So how many natural numbers are there greater than 5? Infinite, right? Infinite natural numbers are there. That is why we'll say it is also infinite, right? Next, D, X belongs to R and X is between 0 to 1, right? How many real numbers are there between 0 to 1? How many real numbers are there between 0 to 1? They are infinite, right? They are infinite. We cannot count the number of real numbers between any two numbers, right? Between any two numbers, we cannot count the number of real numbers. Okay, and the last one, X belongs to N and X is less than 200, right? X belongs to N and X is less than 200. So if X is less than 200, how many natural numbers will be there? 199, right? It is countable. How many natural numbers are there? 199. So that is why it will be what? Finite, right? This will be what? Again, finite. Understood? Because you can count the number of elements in this set. Okay, so these are a few examples of infinite and finite set. All right, now let's go to the next point. Right, next is what? Cardinal number. Cardinal number. Cardinal number of a finite set. Right, cardinal number of a finite set. Okay, the number of distinct element, the number of distinct elements present inside the set, right? The number of distinct elements present inside the set is called cardinal number, right? It's called the cardinal number of the set, right? It's called the cardinal number of the set. So what does this denote? We represent it by n of a, right? If I write n of a, it means it is a cardinal number, right? Number of elements in set A is what? The cardinal number. Number of distinct elements, right, in set A is what? Set of cardinal number. Okay, now, okay, so for example, if A is set of vowels, right, and if I ask you what is the cardinal number of A, so you will count how many distinct elements will be there, right, in this set. So how many it will be there? There are 5. So the cardinal number of this set will be how much? 5. Understood? Now we'll understand the next point, which is what? Equivalent sets. Right? Equivalent sets. Now, two sets are said to be equivalent. Two sets are said to be equivalent if their cardinal numbers are equal. If their cardinal numbers are equal. Right? Cardinal numbers are equal. The elements need not to be same, but the cardinal number should be equal. It means they should have equal number of elements. This implies they should have equal number of distinct elements. Right? Equal number of distinct elements. That is, n of A should be equal to n of B. Understood? There are two sets and there should be n of A should be equal to n of B. For this to be what? Two sets to be what? Equivalent. Okay. For example, if I want to write the example, A is equal to A, E, I, O, Q and B is equal to 2, 3, 5, 7, 11, right? So in this case, number of elements in A is how much? 5, right? Number of elements in A is how much? 5. And number of elements in B is also how much? 5. So we'll say this implies they are what? Equivalent sets. Right? They are what? Equivalent sets. Understood? Okay. Now we'll see the last type of set and then we'll practice some questions. Right? Next is what? Equal sets. Right? Next is what? Equal sets. Right? Now two sets are said to be equal right, if every member of set A is a member of set B, right, and every member of set B is a member of set A, right? Basically what does it mean? It means that both of the sets should be identical, right? Both of these sets should be what? Identical. Basically, it only means the same thing. Both of these sets should be what? Identical, right? So, for example, can I say A and B are equal sets? No, right? A and B are not equal sets. Why? Because the elements, number of elements are same, but the number of elements are not identical. If I write A is equal to A, E, I, O, U, and if I write B is equal to X such that X is a set of vowels, right? X is a set of vowel. Now, if I ask you whether A and B are equal sets, yes, A and B are equal sets. That is correct. Why? Why? Because both of them will be having same elements, right? Identical elements. That is why it will be said as equal set. Understood? Now, there is one note. Please write this note. What is the note? Two equal sets are always equivalent set, but two equivalent sets need not be equal, right? We saw in the previous example, we saw these two are equivalent, right? These two are equivalent, but they are not equal, right? They are not equal. But in this case, these two are what? Equal sets, and they are also equivalent. Why? Because if A is equal to B, can I say N of A will also be equal to N of B? Understood? So this also is a very important thing. You have to remember it, right? It's a note. I think we have completed the theory. Now we'll be practicing some questions on it, and then I'll be giving you homework. Now I'm writing two sets. Tell me whether they are equal or not, right? I'm writing two sets. A is what? A is X such that X is a letter in the word reap, right? And B reap, na? And B is X such that X is a letter in word paper, right? Letter in the word paper, right? So they both, this both are written in which form? This both are written in set builder form, right? Now we need to convert into first roster method, right? Roster method, if I write A will be what? A will be there are only four letters in this, so A, E, R and P, right? A, E, R and P, right? And in B also, if I see A is there, R is there, E is there and P is there, right? P is repeated twice, but we need to just see the distinct elements, right? So how many are there? So are they equal? Yes, they are equal, right? They are equal. Why? Because all the four elements are same as all the four elements as B. Understood? So this is an example of what? Equal sets and also equivalent set. Okay, next. Now I am writing few sets. You tell me whether these are what? Whether these are what kind of set they are. Okay, example of what set. So I'll write first. Identify the type of set. So A is equal to X belongs to whole number. X is between 3 to 10, right? B, alpha, beta, gamma, delta. C, 1, 0, -1, -2, -3, so on. D, 1, 8, -2, 6, 5, so on, right? and E x is such that x is the number of students in classroom, right? Number of students in what? Classroom. Okay, so in the first one, if you see, x is a whole number between what? 3 to 10, right? How many whole numbers will be there? If I want to write down, it will be what? 3, 4, 5, 6, 7, 8, 9, 10, right? So they are what? Finite. They are what? Finite. So that's why we'll say it's a finite set. Understood? The second one, B, is also an example of what? Finite set, right? C, they are saying 1, 0, minus 1, minus 2, minus 3, and so on, right? So it's an example of what? Infinite set. Right? It's an example of what? Infinite set. Then next, D is what? 1, 8, minus 2, 6, 5. This is example of what? Finite set. And last, X is a number of students in a classroom. So how many students will be there in classroom? Obviously it will be countable. So we'll say it's what? Finite. It will be what? Finite. Understood? So this is the example of some sets, right? Now let's practice few more problems. Example, write the set of all integers x such that minus 2 x minus 4 is less than 5, right? Minus 2 x minus 4 is less than 5. So how do we solve this kind of question? In this, what do we do? This is an inequality. You will learn to solve it in the fundamental of mathematics. What you will do? You will add 4 on both sides, right? So if you do, you will get minus 2 plus 4, x minus 4 plus 4, and 5 plus 4, right? So in the middle, minus 4 will cancel. You will get x. This will be 2, and this will be what? 9, right? 2 and 9. So we need to find the set of all the integers between 2 to 9, right? So what will be the set? The set will be 3, 4, 5, 6, 7, and 8, right? The set will be what? 3, 4, 5, 6, 7, and 8. Understood? Okay, next. Second example is, there is a set A, 1, 2, 5, and 10. We need to write this set in set builder method, right? In set builder method. So in set builder method, what will I do? I will write A is equal to x such that x is a factor of 10. Right? A is equal to x such that x is a factor of 10. Understood? So this is the method of writing in set builder method. And the last one, what is this? That if A is equal to x such that x square is less than 9, right? And x belongs to integers, and b is equal to minus 2 minus 1 1 2, right? B is equal to minus 2 minus 1 2. Then we have to find whether A is equal to B or not, right? A is equal to B or not, right? So in this they have given x is such that x square is less than 9, right? And x is an integer, right? In integer, how many integers are there whose square is less than 9, right? So for A, it will be how much? Minus 2 minus 1 0 1 2, right? 0 is also an integer whose square will be less than 9, right? And in B they have given minus 2 minus 1 1 2, right? So obviously A is not equal to B because of what? 0, right? And neither A is equal to B, neither number of elements in A is equal to number of elements in B. Understood? Alright, I hope this is clear to everyone, right? So I'll give you today's homework. All of these things are clear. We have just gone through the definitions and everything. So Today's lecture was very simple and self-explanatory. Just we have gone to the basic part. So today's homework is, right, homework is page number 70, 70 and 71, right? Worksheet number 12, right? Worksheet number 12. Okay, and I think worksheet number 12 and 13. Worksheet number 12 and 13. These two you can do, right? Worksheet number 12 and 13. All right. This is based on sets and the types of sets, right? Sets and types of sets. All right. So let's end today's lecture. I hope everything was clear for today. Today's homework is this. We'll discuss this thing tomorrow, right? 71, I think 72 will also be there. All right. Thank you, everyone. Okay. See you tomorrow.
A very good afternoon. So we are going to learn about animal tissue in this session. Okay. So animal tissue. Yes, this is our chapter. In this chapter, primarily we are going to discuss about epithelial tissue, connective tissue, nervous tissue, and we are going to discuss about muscular tissue. Okay, there are 4 types of tissues that we are going to discuss in animal tissue. Now, in animal tissue, before discussing about animal tissue, let us clear some basics. Okay, let us understand about cell. Okay, so what is cell? We have already learnt in our previous sessions that cell is a basic structural unit of life. Okay, so this we have already learnt, basic structural unit of life. That is what cell is. Okay, the cell, if you see, there are different types of cells, prokaryotic cells, and we have learnt about eukaryotic cells. Okay, prokaryotic cells, which means these cells doesn't have proper defined organelles or nucleus. That is primitive cell. Whereas eukaryotic cell, which means it is advanced cell which has proper nucleus, proper nuclear membrane and full developed organelles. Okay, so we have learnt about different types of cells, eukaryotic cell and prokaryotic cell. Okay, and we have learnt about unicellular organism and multicellular organism, right? In unicellular organism, only one cell is enough for performing different types of metabolic activities, like for any kind of photosynthesis, digestion, excretion. Only one cell was performing. But in multicellular organism, what happens? There is a division of labor. Each function is performed by different type of systems. Okay, and these systems are made up of organs, and organs are made up of tissues, and tissues are made up of cell. So that is the reason cell is a basic, small, structural, basic unit of life. Now, a group of cells, what happens? The cell has a nucleus, plasma membrane, okay? Nucleus, plasma membrane, nuclear membrane, different types of organelles, okay? Now, this is a cell. Now, group of cells, what happens? Let us understand the definition of tissue. So, when coming to tissue, a basic definition of tissue is, what do you understand by tissue? Group of cells which are similar to each other, or you can say similarity in structure. Please note it down, these points. Similarity in structure, similarity in structure, okay, group of cells which are similar to each other or they have similar structures, similar function, and mostly, in most of the cases, similar origin. So tissue, which means it is derived from cells. Cell is the basic unit of life. Now we are learning about tissues. A group of cells come together to form tissues. Okay, the number vary according to the structure, according to the function, the number vary. So group of cells which come together to perform a specific function, okay, similar in structure, similar in function, and in sometimes similar in origin, then it is called as tissue. So basically in this chapter we are going to learn about tissues, different types of tissues. Before that, please note these points. We are going to learn about organ. Now we have learnt about cell, we have learnt about tissue definition, which means group of similar cells which have similar structure, similar function and similar in origin. Okay, that is what tissue is. Now we are going to learn about organ. What is organ? Different types of tissues come together to form a structure, it is called as organ. Okay, for suppose if you take an example of stomach, a J-shaped bag like structure. Okay, stomach is made up of different types of tissue. It consists of smooth muscle tissue. Okay, I'm taking example. Organ ante what must it mean? Organ means the different types of tissues are present. Here I have mentioned about smooth muscle tissue. Again, squamous epithelial tissue. The outermost lining of the stomach is squamous epithelial tissue. Okay, muscles are required for digestion, for involuntary action of the digestion, right? So there are two types of tissues that are forming the stomach. And other cells also present like goblet cells. Okay, and inner part consists of glandular epithelium. Okay, so this organ is made up of different types of tissues. Organ, which means the definition of organ will be here: different types of tissue, which form a structure, to perform similar function. Okay, so here if you see, we have different types of tissues: smooth muscle tissue, we have epithelial tissue, we have glandular epithelial tissue. So these 3 to 4 types of tissues are making one organ, right? So different types of tissue which make a structure to perform similar function is called as organ. Now after completion of organ, what we are learning? We are learning about, we have learnt about cell, we have learnt about tissue, we have learnt about organ. Now we are going to learn about organ system. So what do you understand by organ system? Different types of organ come together to perform a function is called as organ system. In our body, we have different types of systems. For example, digestive system. Okay, we have digestive system. We have respiratory system. Some more examples from your side also. Respiratory system. Any more guesses? Cardiac system, or you can say circulatory system. Okay, nervous system, muscular system. So these all are systems, different types of systems to perform different types of function. For example, digestive system, mainly what it does. What is the function or role of digestive system? Digestive system consists of various organs like mouth, then esophagus, then stomach, small intestine, large intestine. It also have some glands like pancreas, liver. Okay, what is the role of digestive system? It is for digestion of food, breaking down complex food material into simpler form. Okay, that is what digestive system is. Okay, it is performing a one particular function, that is digestion or breakdown of food substances. Now coming to respiratory system. What do you understand by respiratory system? Respiratory system consists of lungs, trachea, nose, nasal cavity. Okay, exchange of gases is the important role that is done by respiratory system. Circulatory system, circulation of blood in veins and arteries is done by circulatory system. So veins, arteries, capillaries, heart, these are the organs that are present in the circulatory system. Now coming to nervous system, it is made up of nerves, it is made up of brain, spinal cord, We have different types of nervous system, peripheral nervous system, central nervous system, right? So these systems are regulating different functions. What is the function of nervous system? We are getting stimuli and we are giving response to those stimuli, right? So that is what the nervous system do. We are responding to the external stimuli. The voluntary, involuntary actions or the actions done by digestion or respiratory system or circulatory system is controlled by nervous system, right? So we have organ system. So this is how our body is built up, okay? Cells which are making up the tissues, which are making up the organs and different organ system and resulting in formation of animal, right? So, as I have told you, there are unicellular organism and multicellular organism. Unicellular organism, only one cell can perform all the metabolic activities or all the actions. But here in multicellular organism, division of labor, which means each action or each function is done by different system. So this is called as division of labor, okay? And cells are the basic unit of life. So this is kind of introduction to the animal tissue. Now we are going to learn about different types of tissue. We have already discussed about cell, unicellular cell or multicellular cells or prokaryotic or eukaryotic cell or cell organelles. Okay. Now here in this session we are going to discuss about tissue. As I've told you, the definition, group of cells, give a hyphen over here, and similar in structure, comma, similar in function. These cells are similar in structure. All cells look alike, okay, and similar in function. And mostly origin is also same, that they are origin. The origin can be from ectoderm, endoderm or mesoderm. Mostly similar origin. Okay. This is the definition of tissues. Now we have learned about tissues which means group of cells similar in structure, similar in function and similar in origin. But our animal body or our body is made up of different types of tissues. Okay. This classification of tissues note down these points. The different types of tissues are epithelial tissue, so this is epithelial tissue. Second, connective tissue, and muscular tissue. And we have epithelial, connective, muscular, nervous tissue. So in animal tissue we are going to discuss all these tissues in different sessions. So in this session we are going to cover about epithelial tissue and connective tissue. Epithelial 1, second will be connective tissue, and third muscular tissue. This is going to be muscular tissue, and this is nervous tissue. So in this session we are going to learn about epithelial tissue and connective tissue, and in other sessions we are going to learn about muscular tissue and nervous tissue. With the name itself you can tell what type of tissue these are. Epithelial, these are outermost tissue or inner body lining cavities which are protecting from external stimuli. Okay. Now coming to connective tissue and muscular tissue. Muscular tissue, there are different types of muscles, that is smooth muscles, skeletal muscles and cardiac muscles. Okay. These are generally present in involuntary and voluntary actions. They are protecting the organs Okay, stomach is made up of smooth muscles, heart is made up of cardiac muscles. Now muscular layer and epithelial layer are linked by, yeah, connective tissue. So connective tissue is basically connecting the epithelial to another structure is called as connective tissue. And we are going to learn about nervous tissue, in which we are going to learn about the structure of neuron. Okay? So these are the 4 types of tissues. Again I am repeating: epithelial tissue, connective tissue, muscular tissue and nervous tissue. The connective tissue is abundant tissue that is present in the body, which is connecting basically one structure to other structure. It is a connecting structure gabatti, which means we are going to learn about connective tissue. Now coming to epithelial tissue. Epithelial tissue. What is the definition of epithelial tissue? What do you understand by epithelial? It is derived from a Greek word which means epithelial. Above. Thelial, which means growth. Epi, which means above, and thelial, which means growth. Something that is growing above a structure is called as epithelial. For suppose there is going to be a basement membrane. Okay? This basement is acellular. Please note it down. Acellular, non-living component secreted by living cells. So basically this is a acellular, which means not made up of cells, and it is consisting of non-living components. Okay, this is called as basement membrane. Okay. Below basement membrane there will be connective tissue, different types of connective tissue. Okay. Above basement membrane, I am talking about above basement membrane, cells are formed. Okay. These cells are called as epithelial. Something that is growing above, right? Above growth is seen. So basement membrane, on the basement membrane these cells are growing, right? That is the reason it is called as epithelial tissue. This is the difference between, this is the definition of epithelial tissue. Okay, something that is growing on the basement membrane. Now as I have told you, basement membrane is acellular, which means it doesn't have any cells. Basement membrane doesn't have cells. It is acellular and it is made up of mucopolysaccharides. Okay, so this is epithelial tissue. Now epithelial tissue also have different types. Okay, so let me erase this. So epithelial tissue is classified into simple epithelial tissue, compound epithelial tissue. Very important, simple epithelial tissue and compound epithelial tissue. Epithelial tissue. Simple epithelial tissue. These tissues are always present on the basement membrane. That's what I have told you, right? Okay, simple epithelial tissue is further classified into subtypes. That is simple squamous epithelial tissue. Then comes cuboidal epithelial tissue. Okay, then comes columnar epithelial tissue, and we have glandular epithelial tissue. Okay, the simple squamous epithelial tissue, cuboidal epithelial tissue, columnar epithelial tissue, glandular epithelial tissue. Before cuboidal also you can write simple cuboidal or simple columnar. It is not necessarily that you have to write. So squamous epithelial tissue, cuboidal epithelial tissue, glandular and columnar epithelial. These are the subtypes of simple epithelial tissue. Now what is the difference between simple epithelial tissue and compound epithelial tissue? Simple epithelium, which is made up of single layer of cells, one cell after other cell, one cell after other cell. There is no cell above these layers. Okay, only one layer of cells are present, then it is called as simple epithelial tissue. Coming to cuboidal, the cuboidal epithelial tissue is made up of multiple layers of cells. There can be 3 to 4 layers of cells. This is called as compound epithelial tissue, whereas simple epithelium layer, which is made up of one type of cells and only single layer is present. Okay, so let us learn about first simple epithelial tissue, then we are going to learn about compound epithelial tissue. So here we are learning about epithelial tissue, epithelium. It is also called as epithelium, the outermost. What is the role of epithelium? It is the lining, internal cavities, internal body cavities. Epithelial tissue, which means it is lining the internal body cavities. Okay, it is present on skin, externally protecting from environmental stimuli. It is protecting from heat, from light intensity, from different kinds of pressure, mechanical pressure. Okay, so skin and organs, lining of the organs, internal lining of the organs or external lining of the organs, all are made up of epithelium. Okay, in this epithelium, now we are going to learn about simple epithelium, simple epithelium, okay. In simple epithelium, we are going to learn about squamous epithelium. So we are going to learn about squamous epithelium. What do you understand by squamous? As I have told you, these are also called as pavement epithelium. Pavement appearance is there, which means tile-like appearance. How tiles are arranged close to each other, that is how tile appearance. Okay. The cells doesn't have proper shape. Okay, these appear like this. This is the basement membrane. Okay, and a single layer of cells are present close to each other without any spaces between them. Let me draw it again. So we are learning about simple okay. So this is basically a basement membrane. On basement membrane, close cells are present, no intercellular spaces. What do you understand by intercellular spaces? Cell and cells have spaces between them, that is called as intercellular spaces. Here we don't have intercellular spaces, they are closely attached to each other. Okay, and nucleus, which is flat and it is present in the center. Okay, when you see from the top view, what happens? It appears to be like pavement. Okay, so this is a single layer of cells, and this is the top view from the upper side. I will erase it, otherwise you will be confused that it will be multi-layered. It is not multi-layered, it is single layer of cells. Okay, so where exactly squamous epithelium cells are present? They are present in the lining of blood vessels. Inner lining, specifically inner lining, small blood vessels. The inner lining is made up of squamous epithelial cells. Okay, so this lining of blood vessel is generally simple squamous epithelial cells. The lining of the capillaries or lining of the blood vessels is Now this is lining of blood vessels, and many more examples we give. Lining of alveoli. Do you know what is alveoli? You must learnt in your previous classes. Alveoli is present in lungs. Okay, these are clusters which are formed, alveolar sacs. Okay, these alveoli are the one where exchange of gases takes place. Okay, these are also made up of single layer of cells or single squamous cells. So we have learnt about squamous epithelium, which is present in the lining of blood vessels, BV, which means blood vessels, lining of alveoli, and where else? Lining of mouth. Okay, what is the role? It generally protects. It is a single layer. It prevents leakage of fluids. Okay, prevents leakage of fluids or exchange. It promotes exchange of gases. And what else? What are the other functions of simple squamous epithelium? It also secretes some substances, and it is also useful in absorption and exchange of gases. Okay, because they are made up of single layer of cells, what happens? Secretion, they are helpful in secretion, some substance secretion, absorption, exchange of gases or excretion. Okay, because they are highly permeable, right? So this is the function of simple squamous epithelium. Now we are going to learn about cuboidal epithelium. Cuboidal epithelium, they also formed on the basement membrane, and the cells appears to be in the form of cube, close to each other. Okay, all are similar in size. Okay, central, round, prominent nucleus is present. From the top view, how it appears? If you take from the top view, this is the basement membrane. Okay, this is cuboidal cells. When you see from the top, it appears to be hexagonal in shape, hexagonal in structure, with no intercellular spaces. Okay, so these are cube-shaped structures or cube-shaped cells that are present on basement membrane. And what is the function or where exactly these are present? Cuboidal epithelial cells present. They are present in various glands, lining of the glands. For example, thyroid. Okay, they are present in large intestine, small intestine. Large intestine in which part? Basically colon. Small intestine, PCT, Okay, proximal cannulated tubules present in nephron, kidneys. Okay, so these cuboidal epithelium. Now there are modification of cuboidal epithelium. There are two types of cuboidal epithelium. Okay, so cuboidal epithelium is of two types. Basically, is a modification actually. If it consists of microvilli, okay, which means protoplasmic extension, small, minute protoplasmic extension of the cell. This is a cube cell, okay, this is a protoplasmic extension, which means microvilli are present, okay. Cilia, these are also, these are originating from basal granules, thread-like structures, uniform in length. Okay, then it is called as ciliated cuboidal epithelium. So here it is called, if it is some projections, okay, then it is called as ciliated cuboidal epithelium. Okay, these are not protoplasmic extensions, these are simple extensions that are formed from basal granules. This is called as cilia. Cilia is required for the locomotion, for the movement. Okay, they are arranged, they have microtubules which are consisting of 9+2 arrangement of microtubules. They are generally for movement. Okay, now this is called as ciliated cuboidal epithelium, which is present in ovaries, okay, in testes. The lining of the ovaries or testes consists of ciliated cuboidal epithelium. Now coming to microvilli, these are protoplasmic extensions, cytoplasmic extensions. They are not for movement. They are here for secretion, absorption, okay, but these are called as brush border. These are called as brush border cuboidal epithelium. So there are two types of epithelial structures over here. One is microvilli, which means it is called as brush border cuboidal epithelium. This is present in PCT, okay, and it is present in various parts of small intestine, large intestine, colon, okay, large intestine. Now coming to this part, this is cilia, which is help for movement, like movement of some substance, forward movement. Okay, here it is seen in ovaries and testes. So this is cuboidal epithelium. Now we are going to learn about columnar epithelium. Tall cells are present on the epithelium. Tall cells are present on the basement membrane. This is basement membrane, and the tall column-like cells which are present close to each other. No intercellular space is present between, because if intercellular spaces are present, secretions or cellular secretion will come outside. Okay, to prevent that, okay, these doesn't have intercellular spaces. These are tall cells. Now the nucleus is present towards the basement membrane. This type of cells are called as columnar epithelium. They are also single layered cells. Okay. Now columnar epithelium are further classified. Okay. Okay, the columnar epithelium cells are further classified into many types actually. Okay, ciliated columnar epithelial cells or epithelial tissue, what you call. It's not cell, epithelial tissue. Okay, so these cells are modified. How they are modified? They have now cilia. Okay, they have cilia, basement membrane, okay. These cilia are helpful for the movement. Okay, so this type of tissue are found in lining of fallopian tube. Okay, lining of fallopian tube. Now coming to another type, if microvilli is present on columnar epithelium, it is called as brush border epithelial tissue. Okay, here the microplasmic extensions are present, small extensions. Let me draw clearly. Okay, these are present in the nasal cavity, trachea. Okay, why? Because they secrete, yes, water, mucus, basically mucus, to prevent, yeah, any movement of dust particles. Okay, so brush border columnar epithelium tissue, then we have glandular columnar epithelial tissue, which means glandular. In this tissue, one cells extensions into the inner part. This is the columnar cells. This goes inside like this. This small invagination or extension is called as glandular epithelial. They release some secretions, glandular secretions, like goblet cells. Okay, they secrete digestive enzymes. Okay, this is glandular columnar epithelium. We have learnt about ciliated columnar epithelium, microvilli or brush border columnar epithelium, glandular columnar epithelium, and there is another one which is called as pseudo-stratified columnar epithelium. Okay, it appears to be multiple layers of epithelium, but cells in between them are smaller. Okay, small cells are present in between them. As a result, it appears to be two. Okay, here the nucleus is present over here. The two layers of nucleus can be seen, which appears to be two layers, but it is a single layer. Okay, so it is called as pseudo stratified. Pseudo, which means false, stratified columnar epithelial tissue. So this is pseudo-stratified columnar epithelial cells. This is present in the lining of the stomach. Okay, these cells sometimes act as goblet cells or glandular cells which secrete some secretions. Okay, so that is the reason it is seen in inner lining of the stomach. So there are four types of columnar epithelium: ciliated columnar epithelium modification, brush bordered columnar epithelium, glandular columnar epithelium, and pseudo stratified columnar epithelium. These are the four types of simple epithelium. Now we are going to learn about compound epithelium. Compound epithelium, there are more than two layers of cells. In squamous epithelium, it was only single layer of epithelium, right? But here, there are multiple layers of this epithelium, okay? Multiple layers of epithelium. 1, 2, 3, 4. 4 layers of epitheliums are present. So this type of tissue is called as compound epithelium tissue. In squamous epithelium tissue or cuboidal or columnar, these are actually basically for the absorption or secretion or single lining, internal lining basically. But compound epithelium is many layers. It protects from the stress, mechanical stress and chemical stress, because their number is more. Okay, they protect from mechanical and chemical stress, from environment, external environment and both internal environment. So any mechanical injury or any chemical stresses, that is protected well by compound epithelium, which is multiple layers. Now compound epithelium is further classified as stratified compound epithelium and transition compound epithelium. What is the difference between stratified compound epithelium and transition compound epithelium? Stratified epithelium has basement membrane, okay, and transition epithelium doesn't have basement membrane. It doesn't have basement membrane, so it is easily flexible. So basically compound epithelium, it is made up of more than one type of cells, one type of cell layer. Okay, it has 2 to 3 cell layers, and it is basically for mechanical protection, from mechanical stress or chemical stress. Okay, and it prevents any kind of injury. Okay, it is further classified as stratified and transition. So according to the topmost layer of the compound epithelium or outermost layer of compound epithelium, it is classified as stratified squamous epithelium or stratified compound epithelium, stratified columnar epithelium. As I have told you, compound epithelium is made up of 2 to 3 layers. Okay, the outermost, the topmost layer shape, according to the shape of the cell, it is classified as stratified squamous epithelium. So here also we have further division. Okay, so let us read about it in a short. Compound epithelium. Okay, compound epithelium is made up of 2 to 3 cell layers, right? This is what I have told. Now this is basement membrane. Cells are present one on other. Okay, if the outermost layer is, the shape of the outermost layer is somehow squamous shape, then this is called as stratified squamous epithelium. If the outermost have cuboidal cells, then it is called as stratified cuboidal epithelium. If the outermost is columnar, then it is called as stratified columnar epithelium. So in compound epithelium, the stratified layers are further, stratified epithelium is further classified as stratified squamous epithelium, stratified cuboidal epithelium and stratified ciliated epithelium. So these are the types of compound epithelium. Okay, so before learning about connective tissue, we have to learn one more important point, that these epithelial tissue doesn't have intercellular spaces. They are tightly bound to each other. Okay, so this is called as junction, cell junctions. Okay, so here we are going to learn about types of junctions, that is tight junction, adhere junction, desmosomes, okay, desmosome, adhere junctions, tight junctions, gap junctions. In detail we are going to learn later, but let us understand the difference. Okay, when cells, one cell, let us take 2 cells image in a larger picture. Okay, when the plasma of the one cell, this is one and this is the second cell, when the plasma of the first cell and the plasma of the second cell are directly in contact and only at certain places these type of junctions is called as tight junctions. Okay, only over here direct plasma contact is present, no other structure. They are very close to each other, no intercellular space is present, they are very close to each other, and one cell plasma connection is with another plasma connection. Okay, so this type of junction is called as tight junctions. Coming to adhere junctions, in between two plasma membranes there is a substance. Okay, there is a substance, thick substance, okay, from which tonoplast or actin fibers are formed. Okay, for example, these active fibers are formed from each of the thick components. Okay, these are very close to each other and they have a substance thickening in between plasma membrane. This is called as adhere junctions. Now coming to desmosomes. Desmosomes are different. They have invaginations towards the plasma membrane. Okay, towards the plasma membrane the invagination is there, so there is a protoplasmic exchange. Okay, this type of junction is called as desmosomes. Now there is a gap junction, which means, okay, two protein channels are present, okay, both sides, and it will allow the passage of substances like water molecules, some ions. Okay, so very thick junctions or thick plate-like structures is formed in adhere junction and desmosomes. Difference between desmosome, these have also protoplasmic extensions which easily transfer substances. Over here they are very tightly bound, like cementing material is present. Okay, and this cementing material is actin fibers which are present, and here they are very close to each other. Tight junctions very close to each other. The plasma membranes are very close to each other in such that the plasma is also in contact, direct contact with each other. Okay, so these are the cell junctions that are present in epithelium layer. Now we are going to learn about connective tissue. So as I've told you, they are present between two structures. For suppose the stomach is present in the abdomen cavity, and the outside it consists of epithelium tissue. The tissue that is present between the organ and the outermost covering, it is called as connective tissue. Okay, it is basically connecting. It consists of matrix. Okay, this consists of matrix. Ground tissue also called, we can call it as ground tissue, matrix. Okay, this matrix is made up of many fibers, white fibers, yellow fibers. What do you understand white fibers and yellow fibers? White fibers, which means collagen fibers, and yellow fibers, which means elastin fibers. Okay, another type of fibers is also present, that is reticulate fibers. This matrix also consists of ground substances. As I have told you, ground substances like mucopolysaccharides, hyaluronic acid. Okay, many different types of cells like fibroblast. These are the one which forms the fibers. The white fibers, yellow fibers are formed from fibroblast. Okay, macrophages. Okay, many other cells, WBC, plasma cells. Okay, many such cells are present in the connective tissue. Okay, basically they are connecting the epithelium. They are present just below the basement membrane, and they also have RBC. They also have blood supply, and they also have nerve supply. Okay, epithelium tissue doesn't have nerve or blood supply. It gets its nutrition from the connective tissue. Basically, connective tissue consists of blood vessels, nerves. Okay, epithelial doesn't have these blood vessels and nerves. They are getting, these cells are getting nutrition, oxygen or glucose from this connective tissue. After connective tissue, we have muscular tissue. Muscular tissue is also basically present on the involuntary and voluntary actions. Wherever the movement is required, the muscle cells are present, okay, muscle tissue is present. And connective tissue over here is basically insulating, it is protecting organs, or it is a ground substance between two structures. So this is what connective tissue is. Now, connective tissue is further classified into majorly we see three types of division over here: connective tissue, loose connective tissue, dense connective tissue, and specialized connective tissue. We have three structures: loose connective tissue, dense connective tissue, specialized connective tissue. Loose connective tissue consists of two types, that is areolar connective tissue, and the second one is adipose connective tissue. This areolar connective tissue is the largest amount of connective tissue that is present in the body, and we have adipose connective tissue, which is made up of adipocytes. What are these adipocytes? They form fat. They are called as fat cells also, adipocytes, which store the fat basically for insulation, for protecting delicate organs like brain or heart or stomach, okay. These are layered, they are a tissue layer which is protecting the sensitive organs, okay, eyeball, eyes, okay. Now coming to dense connective tissue, it consists of two types. According to the fiber nature, the dense connective tissue is divided into dense regular connective tissue, dense irregular connective tissue. This we are going to learn later. Basically learn about dense connective tissue, which consists of white fibers and yellow fibers. Okay, white fibers is made up of, it is also called as collagen fibers, okay, and yellow fibers are called as elastin fibers. This come under dense regular tissue, okay. Now specialized tissue, bones, cartilage, skeletal tissue is also specialized connective tissue, and we have blood. Blood is called as fluid connective tissue. This is very important question for NEET actually. Okay, which of the following is fluid connective tissue? There is only one fluid connective tissue, that is blood. Okay, so these are the types of connective tissue over here: loose connective tissue, areolar connective tissue, adipose connective tissue, which are also having the fat cells, adipocytes. Okay, now dense connective tissue, white fibers, yellow fibers, and specialized connective tissue, bone, cartilage, that are coming under skeletal, blood, which is fluid connective tissue. Okay, now learning about loose connective tissue, the type is areolar. Maximum tissue, which consists of different types of cells like fibroblast cells, macrophages, collagen fibers, elastin fibers, reticulate fibers, okay, blood vessels, nerve tissue, all are present in this matrix, and they are basically majoritarily present between two structures. So this is areolar tissue. Now coming to adipose tissue, this is little bit modification of areolar tissue. In this, they have adipocytes. Other than macrophages, other than fibers, they have adipocytes, which store fats. Okay, we store fats, and this adipose tissue is present in the abdomen region, or it is present near the eyeballs, which is protecting from the mechanical stresses, and it is protecting the heart. Heart is also lined by adipose tissue. Okay, brain, different sensitive organs are protected, and the heat is also for insulation. It acts as an insulator. Now coming to white fibrous connective tissue. In this type of tissue, the matrix is very less amount of matrix is present, and they are made up of collagen fibers. Okay, very hard. The flexibility is very less. White fibrous tissue or flexibility is very less. Why? Because it is made up of collagen fibers. It consists of collagen protein, which is abundant, largest protein abundant in animals. Okay. Example, tendons. Now, who understands about tendons? Who knows about tendons? Tendons are the one which consist of white fibers, okay, which connect muscle to bone. Okay, tendons are the one which connect muscles to the bones. This type of tissue is called as white fibrous connective tissue. Okay, so basically I have told you connective tissue is connection. It is making a connection, right? So tendon is a white fibrous connective tissue which connects muscles to the bone. Why muscles have to be joined with the bone? Because muscles are the one which causes contraction and relaxation. As a result, the bones are pulled, or we can extend our hands. Okay, so this kind of movement or any kind of movement is due to muscles contraction and relaxation, and these muscles are attached to the bones. Okay, how they are attached? Through tendon. This is again an important question. Okay, now coming to why yellow fibrous tissue. It consists of matrix, abundant matrix. Okay, it is basically made up of elastin fibers, and examples are ligaments. The stretchability, the flexibility of the ligaments is high as compared to the tendons. Tendons are stiff, whereas ligaments are very flexible because of elastin fibers. What is ligament? It connects bone to bone. Okay, so we have learnt about adipose tissue, areolar tissue. We have learnt about white fibrous connective tissue, example tendon, and yellow fibrous connective tissue, examples ligaments. Okay. Now, specialized connective tissue, we have two types of specialized connective tissue, that is skeletal tissue and blood. Okay, so the third category, specialized connective tissue. The specialized connective tissue, is having skeletal component and blood component. Okay, so blood is a specialized connective tissue, and skeletal connective tissue is also a specialized connective tissue. In skeletal we have bone and we have cartilage. Okay, so blood is made up of plasma, the fluid part in the blood is plasma, and the cellular part. Okay, the two parts that are present in the blood are plasma and cellular. Plasma is made up of 55% of blood, consists of plasma which is 55%, cellular which is only 45%. The plasma mainly consists of water. That is 90% consists of water. Remaining 7% are the proteins, albumin, globulin proteins, fibrinogen proteins that are present in the plasma. And in this plasma we have cellular component, that is 45. These cells are RBCs, red blood cells, white blood cells and platelets. Okay, so about specialized connective tissue we are going to learn in our next session. Thank you so much.